Welcome guys to Machine Learning and Algorithm full course. My name is Nehemiah and I'm very happy to have you on board. So today we are going to begin from the very basics to the advanced of machine learning. Before then, please subscribe if you have not subscribed. Take a minute, subscribe, like and share the video to your friends. And to the returning subscribers, I really appreciate you very much for your continuous support. And guys, without much ado, let's begin by first understanding what is machine learning. Basically, machine learning is a subfield of artificial intelligence, and basically, machine learning is making the computer learn from studying the data in the statistics. So basically, machine learning is a step into the direction of artificial intelligence. I told you that that is a subfield of AI, and machine learning is a program that analyzes data and learns to predict the outcome. So traditionally, programming uses the known algorithm to produce the results from the data. That is, data plus the algorithms, we get the results. And machine learning creates new algorithm from the results in the data. So basically, the data and the results produced to get the new algorithms. So the other term used here in machine learning is the neural networks, and basically a neural network is a programming technique, and is a method used in machine learning, and there is a software that learns from the mistakes. So basically, neural networks are based on how human brain works. They're made up of perceptrons, and basically neural networks are sending messages to each other, and while they are trying to solve a problem over and over again. Then it strengthens the connection that leads to success and diminishes the connection that leads to failure. So let me talk about basically, guys, you can see this is the human brain, and this is the neural networks here. You can see they're made up of perceptrons, and perhaps let me talk about the perceptrons before I get back to these neural networks. So basically, perceptrons define the first step into the neural networks, and it represents basically a single neuron with only one input layer, and it has no hidden layer. So basically, the neural network, as I said, is a multi-layer perceptrons. It is made up of perceptrons, several perceptrons in a multi-layer. We have, as you can see here, guys, we have the yellow yellow layer, and then we also have the blue layer and the red layer. So basically, this yellow part is the input layer. Then the blue part is the hidden layer, and then the red is the is the output layer. Perhaps let me talk about these stuffs in details. So basically, in the neural network model, input data, this is yellow, processed against the hidden data, which is blue, to produce the final output, which is red. Now basically the first layer, which is yellow perceptrons, these ones are responsible for making simple decision based on the input data, and then each decision is sent to the perceptrons in the next layer, which is blue. Now in this second layer, basically these are the blue perceptrons, and these ones are responsible for making decision by weighing the results from the first layer, which is the yellow perceptrons, and they make a more complex decision at a more abstract level than the yellow perceptron or at the first layer to produce the final output, which is red. Now the other concept here, or the other term here, is the deep neural networks. Basically, deep neural networks, just like the neural networks, this one is a programming technique, and there's a method used in machine learning, and there's a software that learns from the mistakes. So neural networks are made up of several hidden layers of the neural networks that perform complex operation on massive amount of data. So basically, the difference between the neural networks and the deep neural network is that the deep neural networks are made up of more layers than the neural networks. And so basically, I did the structure of a deep neural network, but before then, a deep neural network are made up of several hidden layers, as I said, that performs complex operation on a massive amount of data. So basically each successive layer uses the preceding layer as input. So for instance, optical reading uses low layer to identify edges and higher layers to identify letters. So guys, as you can see here, we have the yellow perceptrons, we have the blue perceptrons, we have the green perceptrons, and then we have the red perceptrons here at the end. And so basically the first layer, of which is the yellow perceptrons, are responsible for making decisions based on the input, just like in the neural networks. And each single decision is sent to the perceptrons in the next layer, of which is a blue layer, where we have the blue perceptrons. And then now in this second layer, the blue perceptrons, these ones are responsible for making decisions by weighing the results from the first layer, the yellow layer. This layer make more complex decision at more abstract level than the first layer. And then we also have another layer here, the green layer, right? Yeah, basically these ones make even more complex decision, and basically when they are done, they send the data or basically the final output, which is red. So guys, basically the other thing here is the deep learning, and deep learning is a subset of machine learning, just like machine learning is a subset of artificial intelligence. So deep learning is a subset of machine learning, and deep learning is responsible for the AI boom of the last years, including um, these are generative AI, like these are chatbots like ChatGPT and all that. And then deep learning is advanced type of machine learning that handles complex tasks like image recognition, text generation, and all that. And so, what is the difference between machine learning and deep learning? So, as I said, machine learning is a subset of artificial intelligence, and then the deep learning is a subset of machine learning. And the machine learning uses smaller data sets, while deep learning uses larger data sets, big data. And then machine learning, they are trained by humans, while the deep learning trains on its own. Then machine learning creates simple algorithms, and deep learning creates complex algorithms. So guys, basically, how do we get started? So guys, before we dive into the course, we need to install Python in our system. Basically, we are going to learn machine learning with Python, and then we will need also to have a notebook where we write our machine learning codes. And then also guys, we need to install the modules. But guys, before you learn this machine learning, ensure that you have at least some skills on Numpy, Pandas, Matplotlib, Seaborn, and all that, because machine learning depends on these stuffs, because they are responsible for data science and all that. So guys, basically let's begin straight away. First of all, let's confirm if you have Python in our system. So to check if you have Python in your system, just open your terminal, your command line tool, like a terminal or a command prompt or a PowerShell or any other terminal or a Conda, any terminal guys, any command line tool. Then just type in a py, then a dash version. Basically it should be version, right? Version. Then I hit enter. You can see mine is Python 3.11.3. I think is the latest. If this command failed, just try Python Python 10 a dash version. You can see still it gives me 3.11.3. So basically this is how you can confirm if you have Python. So if you don't have, let me show you how you can install a Python. So to install Python, open your browser. Like for me, I'm using here Chrome, Google Chrome. You can use another browser, and then I just type in python.org, then hit enter, and then when this page opens, click on the download section, and then download for your operating system. Mine, it has detected it is Windows. That's why you can see it has given me the option to download for Windows. However, just download for your operating system, be it Linux, Mac OS, or any other operating system. So guys, when you'll be installing, the thing that I want to put an emphasis here is that ensure that you click on all checkboxes, because you might want to install the required packages, including the PIP or a TK-INDA. Those are very fundamental packages for Python, like a PIP. It's a package manager to install Python modules or a Python stuffs. So ensure that you click on all checkboxes so that you may install all the required packages. So once you've installed Python, you need to have a notebook where you write your codes. So we can use, there are many notebooks, guys. You can decide even to code on the notebook. I usually come with this operating system for Windows. I don't know for Mac it is what. And then you can also in other, like even Notepad++, you can use brackets, Dreamweaver, Visual Studio Code. You can use PyCharm, the IDE for Python. For me, in this tutorial, I'm going to use Jupyter Notebook from the Anaconda environment. Now, the reason I always opt for Anaconda usually come with all the packages, pre-installed in this environment. So how do you download Anaconda? So just go to anaconda.com, then anaconda.com, then download. Anaconda.com, then I download anaconda.com / then download. Then it will take you to this page, and then I guess you can see it is a free download, and then everything that you need to get started in data science on your workstation. And then it is a free distribution install, and then it has thousands of the most fundamental data science, artificial intelligence, and machine learning packages of which we need in this course. And then you can manage packages in the environments from the desktop application. And then you can deploy across hardware and software platforms. You can choose to code on the cloud, or you can use you can download it on your system. So guys, basically once you have downloaded and installed, let me just open this Anaconda, because for me I already have it. So let me just try to launch it. So guys, basically when you launch your anaconda.navigator application, you'll have this kind of an interface where we have several programs. You can see we have DataSpell, we have CMDX, we have JupyterLab, we have Notebook, of which you are going to use in this course. Then we also have PowerShell, we have PyCharm Community, we have Qt Console, we have Spider, we have other programs here. But for this course, I'm going to use a Jupyter Notebook, and you might also want to follow along, or you can as well use Visual Studio Code or any other fancy program. But for the sake of this tutorial, let me just use this Jupyter Notebook from the Anaconda environment. So guys, basically the other thing guys that you need for this tutorial is to install these packages. For instance, if you don't have an Anaconda environment, you just want to, I say that Anaconda usually come with those packages pre-installed. However, if you're not using Anaconda, you might want to install those packages. And I told you that while you are installing Python, ensure that you click on the checkbox to install the PIP, of which the PIP is a package manager to install the Python packages. For example, if you want to install a Numpy, you can just go to your command line tool, then type in PIP install Numpy, and PIP install Numpy, and then it's going to install Numpy for you. So remember, for me, I already have it. For example, if you want to install a Pandas, just type in a should be PIP install Pandas, and then you hit enter. It will install Pandas for you. And then the other thing that you might need is the Matplotlib. So it is PIP install Matplotlib. Then when you hit enter, it will install a Matplotlib module for you. Remember, for me, I already have it. And then perhaps the other thing you might need also is this the SciPy. So you might want to say PIP install SciPy, and then when you hit enter, it will install for you. But guys, if you're using an Anaconda environment, don't straight to install these stuff. It already have those packages for you. So now once you have launched, guys, I said that click on the launch Jupyter Notebook. And then when you launch it, will take you to your default browser, of which it took me here. And then you can decide where you're going to place your project. Remember, these are folders here is the replica of what you have in your on your file explorer. So for example, if you add here a file at the desktop, it's going to add it at the desktop of your computer. For example, let's say let me place this project at the desktop. And then the other thing that you want to do next is to click on the new, and then choose a Python 3. I chose Python 3. Basically, this is the interpreter that we're using, Python 3. And then once it's opened, the first thing that guys, before you do anything, ensure that you give your project a title. Perhaps let me just call it machine learning full course, and then we can rename it. So guys, you can realize that when you go to your file explorer and then you navigate to the desktop, you can see that we have this file here called machine learning full course. And so this is a place where we are going to write our programs, our code. So let me perhaps try to minimize these other sections. So guys, now that we have everything in place, how do we get started? So guys, basically we are going to begin by first going back to mathematics and study statistics and how to calculate important numbers based on the data sets. And basically we'll also learn how to use various Python modules to get the answers we need, like for example the Numpy modules, like the Pandas and all that. And then we will learn how to make functions that are able to predict the outcomes based on what we have learned. Now, talking about dataset, what is a dataset? Basically, in the mind of a computer, a dataset is any collection of data. It can be anything from array to a complete database. So basically, guys, perhaps let me talk about the data types, because these are also very, very important things to discuss. So basically, to analyze data, it is important to know what type of data we are dealing with. We can split the data types into three main categories. We have the numerical data, we have the categorical data, and we have the ordinal data. Now, numerical data are numbers and can split into perhaps two numerical categories. Like we have the discrete. Discrete is the number that are basically that are limited to integers only. For example, the number of cars passing by. And then we also have another type of numerical category. We have the continuous data, and basically these are numbers that are of infinite value, like for example the price of an item, the size of an item and all that. And then I guess we also have the categorical data, of which are values that cannot be measured up upon each other. For example, the color value, perhaps yes or no values and all that. And then lastly you have the ordinal data, of which these are like just the categorical data, but can be measured up against each other. For example, basically school grades where perhaps A is better than B and so on, the grades and all that. Basically, there are three items which usually interest us on data. For example, if you have numbers, if you have several numbers, you might also want to know what is the minimum value, what is the mean value, what is the median value, and what is the mode value. So basically in machine learning and basically in mathematics in general, there are often three values that you must learn, or it must interest us. That is the average value, of which we call it mean. Then at the midpoint value, that is the median. And then at the most common value, that is the mode. So let's begin by first understanding what is the mean. Basically the mean, I said, is the average value, and to calculate the mean, for example, if you have some data like let's say 1, 2, 3, 4, 5. Now guys, basically to calculate these values, now basically to calculate the mean here, what you're gonna do, you're gonna add these values together, and then you get the results. And then at the results that you get, you divide plus the number, you divide with the number of items here, like for example you have 1, 2, 3, 4, 5. So the summation of these values you divide by 5. And then for mean, basically this is mean. And then for what? For median. For median is that this is the value in the middle after you have sorted all the values, basically in alphabetical order. For example, if you have these values, you have 5 values here, right? 1, 2, 3, 4, 5, and we have sorted in ascending order. We have 1 being the first item, and then 5 being the last item in the ascending order. Once you have sorted your values, then to get the median, you find the value which is at the midpoint of this value, of which is 3. So 3 is the median value. And then for mode, let's assume that you have another value here called 3. So the mode is the value that appears most of the number of times. Like for example, you can see we have 3 twice, but other items are just 1. They are just in each basically single values. So basically the mode is the number that appears several times compared to other values. So in a nutshell, the mean, median, and the mode are techniques that are often used in machine learning. So it is important to understand the concept behind them. Now, basically let's talk about the standard deviation in machine learning. Remember everything, guys, I'll show you with Python. Basically, for example, if you want to obtain the mean, median, and the mode, I'll show you everything with Python. Or basically, perhaps let me just show you with Python before I forget. For example, if I want to obtain the median, for example, I said that we need to import to use some modules here. For example, if you want to get the median, we might need Numpy here. So you will say import. We use the import keyword to import the Python modules, and then and so we say import Numpy. Numpy is an alias. We always use Numpy as an alias. NP. And then here you can say, for example, if let's say, for example, if you have the speed, let's say speed of the cars, and then in this speed we can have perhaps, let me have a list here, just a normal list, a normal Python list, perhaps let's say 20, 80, let's say 30, let's say 10, let's say 180, let's say 60, and what else, let's say 95 or 96, let's say 72, and all that. 7 should be a comma, right? 72. So guys, basically to obtain the minimum value, the mean value here, we can create, for example, let me create an object here for NumPy. Let me use a NumPy now. We use it as an alias NP. Then here you can say mean, and then I pass in what? Let's pass in our list here, of which we gave it a variable speed. So to execute the command to obtain the mean, we just say print. We use the print function to execute codes at the terminal, and then we pass in the variable which is x, our object, and then when you run, you'll obtain the mean. Basically, the mean which is 68, which is 68.5. So basically, this is how you can obtain the mean. And for median, you just instead of mean here, just say median like this, and then you pass speed is your object, and then you obtain 66.0 as our median value. And then what else to obtain the mode? Now to obtain the mode, you just pass here. Basically for mode, guys, we will need also to import another module called starts from the SciPy. So in that case, guys, I have to use we are not going to use an NumPy, we're going to use SciPy. So guys, remember I told you that it's a good practice to have knowledge on these modules: SciPy, Numpy, Pandas, Matplotlib, and what else? And all those modules, including even the Seaborn, because those are very, very fundamental modules for, you know, for data science or machine learning. So we are going to import, so it should be from, let's say from SciPy, import stats, and then now in these stats, guys, we're gonna, it has, of course, once you have it here, you must pass in that function stats, and then these are stats. You can have pass the method here called a mod, and then we are passing here, we are passing speed here, and then of course guys, here we do have a mod, no, or what I do guys, let me just try to give, remember I said that a mod is a value which repeats itself several times. Like for example, let me add in here that so that we may have the mod here. So you can see guys, basically the mod here, you can see it is 30, the mod array is 30, and then the number of repetition, it is 2, you can see it is 2, and then the mod array is in the arrays 30. So basically this is how you can do that, and before I forgot, I had to show you that. So guys, the other thing here, let's talk about the standard deviation in machine learning. And standard deviation is a number that describes how spread out the values are. Like a low standard deviation means that most of the numbers are close to the mean or the average value, while the high standard deviation means that the value are spread out, over a wide range. For example, let me just show you guys. For example, let me create here our data, and then so perhaps I'll show you with the code. Let me just show you with code so that you may understand better. Basically with the Python. So first of all, we are using the Numpy module here. Numpy, you can use it as an alias, or you can just use Numpy itself. Then perhaps let me just try to get the data. Let me just use this data, these values here, and then this is the speed perhaps. Then to obtain the standard deviation here, we can create an object here, and then I pass here numpy, then I pass in standard deviation mode standard. Basically it should be std, and then we are passing what our object is, which is speed, and then to execute the code you just pass in what x in the print function, and then when you run, you'll obtain what? You'll obtain the standard deviation. So let's give it some time so that it may execute this code. So I don't know why it's taking forever, but this is how you can obtain what? The standard deviation. Guys, perhaps on the same, let me talk about the variance. And variance is another number that indicates how spread out the values are. And in fact, if you take the square root of the variance, you get the standard deviation. Or the other way around, if you multiply the standard deviation by itself, you get the variance. Now, perhaps let me explain how you can calculate the variance. Now, to calculate the variance, you have to find the mean. For example, if you have these values, you want to obtain the variance with these values here, guys. What you do, first of all, you find the mean. You find the mean of these values in this list, and then once you find the mean, and then find the difference of each value here from that mean that you obtained. Find the difference, and then once you find the difference for each values here for these basically from the mean, you subtract the mean with these values, and then when you get the values for each the difference from the mean for each values here, then what you do, you square the values. Now once you square the values, basically to obtain the variance, now it is the average of these summation of the squared values here. That's how you can do it. That's how you can obtain variance, or you can as well use it with Numpy. Now guys, basically to use Numpy you have to use the VAR method to find the variance. So let me show you, perhaps let me just use the same here. To obtain the variance here, you just use this method called VAR, and then when you run, you'll obtain what? You'll obtain the variance. You can see it is quite easy, right? Other than finding the mean, subtracting the or getting the difference from the mean, and then squaring the values, and then calculating adding the values together, then doing the average. It's quite a long method, but you can see with the NumPy it's quite easy. And then for standard deviation, as I've showed you earlier, basically the formula to find the standard deviation is the square root of the variance. The square root of the variance, that is what? The standard deviation. Or you can as well use the NumPy to get the standard deviation. I think I showed you earlier. You just say here, instead of VAR, you just say ST, STD for standard deviation. Then you'll do what? You'll obtain, you'll obtain the standard deviations. So guys, in a nutshell, standard deviation and variance are terms that are often used in machine learning. So it is very, very important to understand how to get them and the concept behind them. So guys, basically the other thing that we have to understand here in machine learning before we dive deeper is the percentiles. And percentiles are used in statistics to give you the number that describe the value that a given percent of the value are lower than. For example, if you have these values here, if you want to obtain the percentiles, for example, if you want to obtain the 75 percentile or such stuffs, what you do, just type here instead of standard deviation. Of course, we use NumPy, and then guys, that's why I see that it is important to learn NumPy, because you can see it is very, very fundamental here. So what you do here, you just pass in percentile like this, and then perhaps if you want to obtain the 75 percentile or the upper quartile, or what you do, just say 75 if it's 75%. What you do then, guys, you can see when you run, you'll obtain what? You'll obtain the 75% percentile. If you want to obtain 25, you just say 25 percentile. 25 percentile, when you run, you'll obtain the 25th percentile and all that. And so I think, guys, you've understood that. So guys, let me talk about the data distribution in machine learning. And guys, basically we've been working with a few data sets, with a few data here in our example, just to help us understand some of the basic concepts. But in the real world, the data sets are much bigger. It can be difficult to gather the real world data, at least at an early stage of a project. But how can we get big data sets? So guys, basically to create a big data sets, basically for testing, we can use the Python NumPy module, which come with a number of methods to create random data sets of any size. So for example, let's create an array containing perhaps, let's say, even 300 random floating numbers, perhaps between 0 to some values like let's say 5. What you do, first of all, you import the module with the import keyword. I import NumPy. I like working with NumPy as an alias, NP. And then remember, alias is the other name for something, or the shorter version of something. But in that case, when you are defining an alias, you have to use this keyword, AS keyword. And then now, guys, let's create our object X. Then let me assign it to the NP for NumPy. And then we are going to use the random method, random. And then it's going to be a uniform distribution, uniform. What is spelling for uniform? And then and let's give the range here. So it's gonna be a floating number, perhaps from 0.0, and then the highest value will have what? Will have perhaps 5.0. 5 should be 5. 0.0. They're both floating numbers, and then the numbers that you want to generate here, perhaps let's say they are 300. You want to generate, or let me just even say 30,000. You can generate any number here, but 30,000 will be quite many. Then let's say print perhaps let's say x. So guys, basically in this case it will generate random floating numbers ranging from 0.0 to 5.0, and those numbers are going to be 30,000. So let's try to run and see if it's true. So guys, basically you can see the list is quite big. That's why it has given us, you know, the first just three values, and the last, you know, three values. Let me try to reduce the number so that it can try to give us everything here. Perhaps let me even use 200 like this, and then let me just try to run, and then you can see for 200 it has given us. You can see for 300 it was quite many. It couldn't, you know, print out, but for 200 it has done so. So basically this is how you can do that. And then guys, perhaps if you want to visualize the data set, you can draw a histogram with the data we collected. Like for instance, these are values here. So basically to visualize or to draw stuffs, we have to use the module called Matplotlib to draw the histogram. So guys, perhaps let me show you how you can access other courses. Just go to YouTube, and then just search for name tech. Let it open, then I just search for name tech. I remember I'm using the same account. I don't know if it will bring. Let's search for name tech, and then basically this is the account, and then click on this logo here, and then guys, you're going to have you can see we have many videos here. You can see we have more than 183 videos. So go to the videos, and then guys, you can see we have many courses, including the SciPy courses, Matplotlib courses, Pandas, Numpy, file handling, and many other courses are available here. Guys, you can check them out, and then you are gonna have some free access to these resources, and they're gonna be quite helpful. So how do we draw the histogram based on this data here? So to draw the histogram, we have to use the Matplotlib function. Let me copy these values, then to the new cell, let me just paste it there, and then here let me say import, Matplotlib, but you can't use Matplotlib alone. You have to use the other submodule called pyplot. Pyplot is, you can see, it's quite a long name, so you have to use it as an alias, PLT. Then this is our random number that we want to use, and then now basically to visualize you use the Matplotlib function. For example, to plot first of all the histogram, we say PLT. Remember, it's the alias for Matplotlib.pyplot, and then now basically the alias for pyplot, and then here let's say hist, and then let's pass in what our object, and then now let's give it what, let's give it let me give it here 5, then let's try to visualize. Let's say PLT, because basically I'll want to have 5 what, I'll want to have 5 bars in that histogram. Then let's say PLT dot, basically to visualize, PLT dot show, then let's try to do it. Let's try to run and see if it is true, if it will visualize. And then guys, basically you can see it has visualized, and then we have what, 5. Remember, we specified here the histogram to have 5 bars, and then you can see you have 1 2 3 4 5 bars. So basically this is how you can visualize. And again, remember to use an account environment, otherwise you'll have to install the GUI compilers for Matplotlib. So it's a good practice just to use the the Anaconda environment. Let me perhaps talk about the big data distribution. And you saw earlier when we tried to use a 3000, it didn't, give us, everything. It just gave us the first three and the last three values. So basically, an array containing about these are 200 values, 200 numbers. These are not considered to be big data. But now you know how to create a random set of values, and changing the parameters, you can create the data set as big as you want. For example, you can as well do what you can as well generate what even 1,000, the 1,001. Like for example, or let's just say for example even a 200,000 like this, and then what to do for this histogram. Perhaps I can try to give it several bars. Perhaps let me give it even 100 bars in this case, and then let's try to visualize. So as you can see, it's quite big, right? So basically this is how you can do that. So guys, let me now talk about the normal data distribution in machine learning. So basically now I want us to learn how to create an array where the values are concentrated around a given value. And in probability theory, this kind of data distribution is known as the normal data distribution, or sometimes the Gaussian data distribution. After that, mathematician Carl Friedrich Gauss, who came up with the formula of this data distribution. Now, let me just show you that, guys, how you can do that. Basically, for normal, just for example, this one is an example of a normal. Let me just show you, for example, an example of a normal distribution. And guys, I remember I said that a normal distribution, basically a normal distribution, values are concentrated around a given values. So, for example, let me just say a normal, and then what I do, let me just try to run guys and see the output. So you can see there's an error somewhere, right? Random. So in this case, guys, let me just try to modify here a bit, and perhaps let me just try to use some values here that are quite, let me say for example 5.0, and then what is 5.0, and then perhaps let me use here 1, also 1.0, 1.0 like this. Oh guys, basically I see the error. It should be normal. I was shocked how it failed. So it is normal. I wrote normal. You can see it should be normal distribution. And then when you run, you'll obtain what these are, normal distribution like this. And I say that these are normal distribution values are concentrated around a given, values. You can see. That's how you can do that. In so case, remember that a normal distribution graph is also known as the bell curve because of its characteristic shape of a bell. You can see. So basically, that's how you can do that. Now, so guys, let me now talk about the scatter plot. Let me talk about the scatter plot. We've been using these, these are histograms. But let me talk about the scatter plot. Now, a scatter plot is a diagram where values in the datasets are represented by a dot. So, in that case, perhaps let me just show you something here, guys. Let's create our X and Y arrays, and we'll use the scatter method to draw the scatter plot for the values here. So first of all, we are going to use what the Matplotlib. Let me just copy this line of code and try to zoom in a bit for you to see what I'm doing here on the screen. And then now let me do this. Let me create some values, the x-axis values. I can give it a list of values. Perhaps let me use 10 values. Perhaps let me say 3, 4, 5, 6, 2, 4, 10, even 9, and then 12. how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. Then perhaps let me add in one here. Perhaps let me use 7. This for x-axis. Now for y-axis, I can use some values like even let me use 99, for example, 87, 21. Let me use 100. Let me use that is 6. Any random values, guys. Even 77. Even 36, 45, even 90, even 150. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let me say, for example, 111. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, they must tally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure, they are 10, 10. For it to work, you have to have the equal numbers in the x and y axis. Now, to visualize a scatter, you can say plt and then a dot scatter, and then we are going to pass in our x and y axis, and then also to visualize, we are going to use the plt. Remember, plt is the alias for pyplot. Then let me say show, then show is a function, so you have to use it, and of course here it should be a dot, not a comma. Should be a dot. And then let's try to visualize, guys. Let's run and see how it looks like. So guys, as you can see, we have generated these values here, and so this is how you can do that. And of course, you can as well do with the random data distribution. So basically, in machine learning, the data sets can contain thousands or even millions of values. So you might not have the real world data when you are testing an algorithm. So you might have to use randomly generated values. So guys, basically, as I told you earlier, as we discussed earlier, Numpy can help us with that to generate those random values. So like I'm going to show you how you can create two arrays that are both filled with perhaps 1000 perhaps random numbers from a normal data distribution. And then on the first array, I'll give it perhaps a mean set to be perhaps 5 with a standard deviation of 1.0. I'll show you. Let me just show you guys for you to relate what I'm saying. So first of all, we are going to import the module. Let me copy these two lines of code because I don't want to repeat the same stuff. So the first line is numpy. Let me just paste it here. Perhaps let me try to zoom in a bit. So it is a plt, right? Plt. And then here, let's generate random values here that has a mean of perhaps 5 and a standard deviation of 1. So what I do, let me create the x-axis, then assign it to, let me assign it to numpy. I'm going to use numpy.random, then dot normal, and then I say that I give it a mean of 5.0, a float number, and then the standard deviation, I can give it even 1.0, and then the values that I want to generate, they are 1000 values. Now this is for the x. Now for y, here I'll change here to y, and then perhaps I can change the mean to be perhaps, let's say 10, and then the standard deviation I can give it even 2. This one is for the y axis. How do we plot now such a big data? So what we do is just say plt dot scatter, and then let's pass in our values, our x and y values. So x, and then a y, and then to visualize, we'll say plt dot show, And then what I do, let me run. And then guys, basically you can see this is how you can do it. This is how you can generate such big number of values. So guys, as you can see that the dots are concentrated around the values, the value of 5, around 5, you can see they are quite concentrated here on the x-axis, and on the y-axis they are concentrated around what? Around 10, you can see. It's concentrated in these regions. So so we can see that the spread is wider on the y-axis than on the x-axis. So guys, basically that's how you can do that. So guys, let me now talk about the linear regression, and this one is a very important aspect in machine learning. You have to be keen here to grasp some concept here. So remember, the term regression is used when you try to find the relationship between variables. So in machine learning and basically in statistical modeling, the relationship is used to predict the outcome of the future events. And that's why I say that it's very prudent for you to be keen here to understand the concept. Now, the linear regression uses the relationship between the data points to draw the straight line through all of them, and this line can be used to predict the future values. So in machine learning, predicting the future value is very important. But how does it work? Basically, Python has method for finding a relationship between data points and how to draw a line of linear regression. And I'll show you how to use this method instead of going to the mathematics formula. It's quite hectic. So let me just show you guys an example. For example, how you can draw the scatter plot. And of course, let me just create some values here. Let's begin by first drawing the scatter plot. Let me use what? Let me use Matplotlib here. Let's draw some values here. I'm gonna use some symbol data set here, some symbol data. This is Matplotlib, and then let's create our list. So perhaps let me say, for example, 5, 7, 8, 7, 2, 17. You can use any other values, guys. 2, and then 9, and then perhaps 4, 11. You can even use 12, 9, and let me use 6. And then for x-axis, remember how many are there? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. Now for y, let me use 99. Let me use 86. Let me use 87. Let me use what? Let me use 88. Let me use 88. Let me use 111 perhaps. Let me use 86 again. Let me use 103. And let me use 87. You can use any other values, guys. You can use 94. I'm just generating my random values here, and then let me say 78 perhaps, 77, 85, and then 86. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Quite perfect. And then here let's draw our scatter plot first of all. So let's say PAT dot scatter. Then let's pass in the values of the x and y axis, and then let's try to visualize and see how it looks like. So PLT dot show function to visualize, and then let's try to see how it looks like. So as you can see, this is how this is how it looks like. So in this case, guys, I just assume that the x-axis represents what? It represents the age, and then at the y-axis represent the speed of cars. Basically, x-axis, this is the age of a car perhaps. Then at the y-axis, this is the speed of the car. So like in this case, we used 13 values. Let's assume that we registered 13 cars and they were, passing a toll booth. So let us see if the data we collected could be used in the linear regression. And so basically you can see this is the result first of all. And so guys, I want to draw the line of a linear regression, and in that case, guys, you have to use the SciPy. Remember we imported SciPy. So let me just use the same data. Let me copy, because I just want to use the same so that I may not lead you astray here. Let me just use it. And then guys, I said that you have to use SciPy here, but under SciPy you have to use the stats as a module. So I'll say from SciPy module, guys. I told you that it's very important to learn these modules. Remember, I have it on this channel. Just go to the videos, then search for SciPy. You'll find a full course there on SciPy, and then just learn it. And then guys, basically now from SciPy import stats. When you have this module here, you can then draw your line of linear regression. Now, how do you do that? Basically, in that case, guys, I have to pass here some functions here. First of all, it will be the slope, and then intercept, and then also the R, and then P, and then STD for standard deviation, basically standard deviation, then standard deviation R, and then let's assign it to the stats module, stats dot linear. It is called lean regress for linear regression, Then let's pass in the values of x and y. Let me use now here a function. Let me define a function here with a div keyword. Then my function, let me just call it my func, or any other name, my func. What is the spelling for? Anything, guys, any name, provided you call with the same name. And then here we are passing x. And then let's close. And then I want us to return the slope, and then I will multiply with the x, and then apply the intercept like this. And then here, let's say let me create a model here. Let me use my model variable. Then let's assign it to the list. And then here is gonna be, we're gonna pass in map method, and then in this map method we are gonna call the function. We're gonna pass in the function remember, once you define a function, you have to call it my func like this, and then x, and then x, and then what we do, guys, here at the plot we have to plot it. So I'll say plt, then a dot plot, plt dot plot, and then we're gonna pass in x, and then also that module, or which you call it my module, right? It should be my model, my model like this. And then what we do, let me run and see if it will work. Yeah, sure, guys, you can see we have now the line for a linear regression. So you can see, guys, how perhaps let me try to explain. So first of all, guys, in this case we imported the modules that we need for this for this plotting, of which we used Matplotlib for visualization, and then also SciPy. We also used SciPy to get that module for linear regression, and then we executed the method that returns some important key values of linear regression, of which are here. So these are very important methods which help us to return some important values of the linear regression. And then guys, here we created a function that uses the slope and intercept value to return a new value. This new value represents where on x the y-axis and the corresponding x-axis x value should be replaced with this function here. And then guys, basically what we did next is that we ran each each value of the x array through the function, and then this will result to a new array with a new value of the x-axis with this line of code here. And then we draw the original scatter plot, of which we use this method here. Basically, this function here, scatter function. And then also we draw the line for linear regression with this function. We passed here the this x and then also what, and then also my model here. So and then of course the visualizing, the show function is a function to visualize. Perhaps you saw I used here R. Let me try to talk about this R for relationship. Now, basically, it is important to know how the relationship between the values of the x and the values of the y-axis is. And if there are no relationship, the linear regression cannot be used to predict anything. So basically, this relationship, the coefficient of correlation is called R, and R value ranges between -1 to 1, where 0 means no relationship, and 1 and perhaps -1 means that there's 1,100% relationship. They are related 100%, when you have a -1 or a 1. So guys, basically let me perhaps show you an example here. For example, how to obtain how well your data fit in the linear regression. So what I'll do here, guys, let me just copy these lines. Let me copy these lines, and then let me just pass it here. And then now, guys, I want to execute R. Let me say print R. So in this case, guys, we'll try to see if our data fit in the linear regression. Let me just try to run, and then guys, you can see it is it is -7 point. When you round off, it's like 7.6, which shows that there is a relationship, though not a perfect, but it indicates that we can use the linear regression in the future prediction, because it is past. It is let's say it is more than 0.6, or let's say it's more than 5. When you have values more than 5, then just know that around 0.6, you can use those values to predict your future values. Now, how do we predict the future values? Now, we can use the information that we've gathered to predict in the future values. For example, let's try to predict the speed of a 10 years old car. And so, in that case, guys, I'll do what I'll just use. Let me copy this function. Let me use this function. Let me just paste it here. Let me just paste it there, and then remember it will pull the data here at the top, so I'll not have to repeat everything here because it will pull the data here. So perhaps let me say the speed of a car. Let me say speed. Let me assign it to my function my func. Remember, you have to call a function once you have defined my func. Then let's say perhaps 10 years old car, and then let's try to obtain what? Let's try to predict the speed of a 10-year-old car here. So I'll say print what we are printing speed of a 10-year-old car, and then you can see it will be 85.55 that's like a 5.6, right? which also could be read in the diagram. Like let's try to check it out. So like a 10 year-old car. So it will be like when you try to read it manually from for 10 I think it's somewhere here. So when you go to this way and then this way, you can just get it is 85 point something. So let's now create an example where the linear regression will not be the best option to predict the future value. So let's say, for example, I have 89, 43, 36, perhaps 36 again, and then perhaps 95, 10, perhaps 66. And I guess you might also want to use the same values that I'm using. Let me try to zoom in, because these values will give us, the wrong or basically the bad accurate score. And then 66, and then 34 perhaps, then perhaps 38, and then perhaps let's say 20, 26, 29, and then what is let's say 48, let's say 64, let's say let's have about something like even 6, let's use even 6, 5, even 36, any random value, so that's 6, and then 66, 72, and then 40. This is for x. Then for y, let me use perhaps 21, let me use 46, 3, and then perhaps 35, let me use 35, and then let me use something like 67 perhaps, let me use 67, 95 also, let me use what, let me use 53 perhaps, let me use 72, let me use 58, let me use 10 perhaps, let me use 26, let me use perhaps 34, let me use 90, let me use 33, let me use 38, 20 also, and let me use 56, let me use what is 2 perhaps, let me use 47. I'm using these values intentionally because I want us to have a very, very bad score. 15. And so guys, basically let's try to do it. Let's try to run. Let me run, and then guys, you can see how it looks like. It's not quite good. Of course, we're gonna measure the relationship here. Let's try to measure the relationship. Let me copy some values somewhere, and let me use these values. Let's try to obtain the relationship. Let me just run this value and just check it out, and then oh guys, basically I should have used these values. Let me copy what, let me use the value. Remember, you have to use the same values. So let me use these values, because yeah, let me just paste these new values here, and then let me try to run, and then again you can see it is very, very bad. This one indicates that there's a very, very bad relationship, because it is 0.0. 0.0 is very, very bad relationship, and it tells us that this data set is not suitable for linear regression. And so we have to look for another option here, and that drives us to another thing that we have to discuss, which is called the polynomial regression. So basically, polynomial regression, like the linear regression, uses the relationship between the values, basically the variables x and y, to find the best way to draw a line through the the data points. So how does it work? let's say Python has methods for finding a relationship between data points and draw a line of polynomial regression. And I'll show you how to use it, the methods instead of going through the mathematics formula. Like I guess I'm gonna show you here an example where we perhaps will assume that we registered 18 cars as they were passing a certain toll booth, and then also we will register basically the car speed at the time of the day, perhaps where they were passing by. And then guys, what I do, let me just show you that. First of all, let's import Matplotlib and the module. So it is that control plus C to copy, and then let's paste it here. Let's create our x-axis with the list of values here. Perhaps let's say 1, 2, 3, 4. Basically, let me say 3, and then let me say perhaps 5. Let me use 6, 7, 8, 9, 10, perhaps 12, 13, 14, and then 15, 15, perhaps 16, 18, and then 19, perhaps 19, and then 21, and then perhaps 22. This for the x-axis, and then remember there are how many? They should be 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, surely 18. And then for y should be equal numbers. For speed, but remember there's a car. And then remember the speed here, perhaps let's say 100, 90, 80, 60 perhaps, and then also 60 again, and then 55, and then 60, and then 65, and then 70, and then what else? Let's say 70 again, and then 75 perhaps, and then let's say 78, 78, and then 79, 79, and then 90, and then 99, and then 100. Be sure that they are how many values they are? 18. Let me try to count 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. They are not 18. So 99 perhaps I'll also add here 99. What is 90, 90, 80, 60, 60, 55, 60, 65, 70, 70, 75. Let me also add here perhaps 76. 76, and then what we do, let's try to draw the scatter with this function plt dot scatter, and then let's pass in the x and the y, and then also we might want to visualize. How do we visualize? Plt dot show, and then what I do, let me just try to run here. Guys, you can see you have these values. So guys, as you can see, this value is not fit for linear regression, because I remember I told you that linear regression is just a straight line. To draw the linear regression to be a straight line, but it won't be fit for this kind of graph, because you can see it's kind of a curve, So in this way, we have to use what the we have to use here the polynomial regression. So how do we go about that? So to do that, you have to import what? Let me copy the same value. Then let me use it in the new cell here. Let me paste it here. Then here we have to import. Let me zoom in a bit for you to see. And then let's say import Numpy. Let's say import Numpy. And then here what we are gonna do is let's say let me create the model. So let me say my model. Then let me assign it to the Numpy. Let's say Numpy. Numpy, and then let's say let me use perhaps poly. I want to use here 1D, one dimension 1D. Then let me assign it to the Numpy. Let me assign it to the Numpy. Numpy dot polyfit method. And then here we're gonna pass in the x, y, and then let me use a 3 here. Then for the line, let me call it my line variable. You can use another variable name to define your object. Then here is gonna be numpy dot line space. Let me give it 122 and then 100. And then here we're gonna draw the scatter. And then also for the line we're gonna use a PLT. Should be PLT dot plot. Then it's gonna be my line. Then we're gonna also pass in my model like this. And then what is and this method I'm gonna pass in my line again. Let's try to visualize and see if it will work. So of course there's an error. Should be poly, not a poppy. Should be, where is it? Here it should be poly 1D like this. Then line space. There's an error, right? Line space should be lean, not line. Should be lean space like this. So guys, you can see it does. So guys, basically you can see this one is very fit for to predict the values, the future values. So guys, basically this is how you can do that. And of course it is important to know how well the relationship between the values of the x and the y-axis is. If there are no relationship, then the polynomial regression cannot be used to predict anything. So basically the relationship is measured with the value called the r-squared. Now here we use the r-squared. Now the r-squared value ranges between 0 and 1, where 0 means no relationship completely, and then a 1 will mean that there is a 100% relationship. So basically Python and sklearn module will compute this value for you, and all you have to do is to feed it with the data, the x and y arrays. So let's import first of all those modules. And first of all, let me select all, and then here guys I'm gonna use the sklearn. Let's use sklearn. So let me say from sklearn dot matrix import r-squared. So we use r2 underscore score, and then of course here we are passing this function here, and then let me remove this one. And of course we are not visualizing, we want to obtain the relationship, so we are going to use the print, and then here we will pass in the r-squared r2 underscore score, and then in this method we are going to pass in the y, and also we will pass in my model my model, and then dot let's pass also x. So what we do is let's try to run and see how it looks like. So guys, you can see this one is very perfect for our to predict our future values. You can see it is 0.9, 0.9. This one shows that it's a very perfect relationship. This one is close to 1. Remember I said that a 0 means there's no relationship, and then a 1 shows that there's a perfect relationship. Now this one is 9.4. This one shows that this kind of a very perfect relationship, or a good relationship, as you can say. And we can use these are polynomial regression to predict our future, to predict the future values. How do we predict? Now we can use the information that we have gathered to predict the future value. And then for example, let's try to predict the speed of a car that will pass the toll booth at around 11 p.m. So to do so, guys, basically we need the same model, my model array. Basically we need this in my model array, and then let's pass here. Let me just paste it here. Remember, it will pull the other data above here. We don't have to repeat everything. It will pull the data from these other cells, and then now here I'll create the speed. Let's say speed at what time. Speed, we'll use that my model array, my model, then we're gonna pass in paths. Let's say 17 p.m. 17. Then let's pass in the speed. Actually, let's say print, and then let's pass in what speed. And then guys, let's see the let's see the prediction here, and then I will try to relate it. You can see it is 88.87. How do we confirm? So you can see it has predicted a speed of 88.87, which also could read from the diagram. So like let's say try to check out when it is at 17. I don't know 17 is where. 17, let's assume it's here or somewhere here. It's like 88, like what we predicted here. Multiple regression is just like the linear regression, but with more than one independent value, meaning that we try to predict a value based on the two or more variables. So guys, basically, how does it work? So in Python, we have modules, like I told you while we were introducing this Python, we have modules which are very important for machine learning. Modules like Pandas, of which you are going to use here in a few. And so let's begin by first importing the module. Remember, we installed, or if you're using an account, it is already available there. So just say import Pandas. You can import it as a PD alias, but let's just use it the way it is. And then guys, basically we can have some values, some data sets here. Let me just I have some data sets in my system. I'm gonna use it. Perhaps guys, let me try to place that file in the same directory so that we may not struggle with the file path. So let me find it is at the downloads. Let me copy these files. It's a CSV file containing some data. Let me paste it here. I think I placed the project here at the desktop. Let me paste it there. And then now guys, basically once you have imported the module, of course you can use it as an alias. Let me use as a PD alias. And then now to import it, let's have our data frame, the variable for our data frame. And then let me assign it to PD. Remember, PD is the alias for Pandas. And then I want to read that CSV file. It's a CSV file, and then so it is read CSV file. You can as well read the JSON file, but it is CSV for this case, the file that I have. And then now the file name is data.csv, and then so guys, basically with this command, we are gonna do it. We are gonna read this file. However, let me just show you how you can do that. First of all, let me say print, and then let's pass here that data frame variable df. And then let's try to run, and then guys, you can see we have some values here, which you are gonna use it. Now, guys, basically now the next thing is to make a list of independent values and call these variables anything. Perhaps we can call it x. So what I'll do here, guys, let me just say x, x, x. So this is the independent variable. Let me use the x, and then assign it to that df. And then pass in here a list of perhaps let's say weight. Let's say weight. And let's say a weight, and then let me use w weight. And then the other thing, let's use what? Let's use volume perhaps. And then the other thing here, let's for the dependent values in this in this variable y, we can use df, and then let's assign it to maybe carbon dioxide emission. Yeah, guys, you can see we have CO2 emission. So basically I'm targeting the weight in the CO2 emission. So here I'll pass in here, it's a string, remember, it is CO2 sorry, CO2 carbon dioxide. And then let's and then guys, basically it is common to make the list of independent values with the uppercase. For instance, we used here capital X, and the list of dependent values with the lowercase like y. It's a good practice to do that. Now, guys, basically we use some methods from the sklearn module. So in that case, guys, we have to import the module as well. So it is from should be from sklearn import perhaps linear model, less linear underscore model, linear underscore model. Then guys, basically from this sklearn module, we will use the linear regression method to create the linear regression object. Remember, this object has a method called fit that takes the independent and dependent values as parameters and fills the regression object with the data that describe the relationship. And so in that case, for example, let's just here at the bottom, I can say, for example, let me just give the variable regress for regression. Then let me assign it to that method, this function here. Let me just paste it here, and then guys, here let me say dot linear regression method, linear regression, and then is a method. And then now let's let's call this regress, then dot fit, and then we can pass here our independent and dependent variables here. So dependent, it was capital X, then independent, it is Y, right? And then now, guys, basically now we have a regression object that are ready to predict the the carbon dioxide emission. Basically, the carbon dioxide values based on the car weight and volume. So, guys, let's now try to predict the CO2 emission of a car where the weight is perhaps the weight should be something like we'll try even with the 2200, basically 2300 kilograms, and the volume perhaps to be 1300 cubic meters. So what we do, guys, in that case, we have to let me create a variable here. and then I'll call it perhaps let me say predicted CO2, and then I'll assign it to regret dot predict, and then we're gonna pass here a list of those values. So it's a two-dimensional array, so it will be 2300. I say 2300 for what? 2300 will be for 2300 will be the weight, that is in kilograms, and then the volume will be 1300. So I'll say 2300. Remember, you don't have to mention the units, and then 1300 cubic meter, that is for volume. So here the print function, we're going to pass here that variable predicted C. Let me just copy this, because you have to use the exact name for it to work. And then so guys, basically before we run, this one also should be a two-dimensional array here. So it should be a two-dimensional array, it should be a two-dimensional array this way. So what I do, let's try to run and see the output there. So you can see it is 107.2087328. So that's the results. So we have predicted that a car with 1.3 liter engine and the weight of 2300 kilograms will release approximately 107 grams of carbon dioxide for every kilometer it drives. So guys, let me now talk about the coefficient. Coefficient is a factor that describes the relationship with unknown variables. Like for example, if x is a variable, then 2x is x 2 times. Now if if x is a known variable and the number 2 is the coefficient, then in this case, for example, we can ask for coefficient value of the weight against the carbon dioxide emission, and for volume against carbon dioxide emission. Now basically the answer we get tells us what would happen if we increase or decrease one of the independent values. So guys, perhaps let me just show you that example here. So guys, let's now try to print the coefficient of values of the regression object. So what we do here, I'll change here from this predicted CO2. Perhaps let me just also delete this stuff, and then what I do here, the print function, let me pass here this function here. So let me pass here a regret dot coefficient. For example, if we want to find the coefficient coef with, it ends with an underscore like this, and then when you run, you'll find these values, you'll get the values here. So basically these are the results. Perhaps let me try to explain here. So basically guys, you can see the results. The result array represent the coefficient values of weight in the volume, because that's our main target here. Now 0.007555095, this one represents the weight. Then at the volume it is these ones. So like these values tells us that if the weight increased by 1 kilograms, then the carbon dioxide emission will increase by this will increase by these values here, 55 0.007555095. And if the engine size volume increased by 1 cubic meters, then the emission will be this one, will be this one in kilograms. So guys, let me now talk about the scale. Now, when your data has different values and even different measurement units, it can be difficult to compare, to compare them. So, like for example, what is the kilogram compared to meters? It doesn't make sense, or altitude compared to time. So, to answer this problem, we have to scale. We have to apply scaling. We can scale data into new values that are easier to compare. So like for example, we have these data that we use in multiple regression, just in a few. So guys, you can see initially it was 1000 cubic meters, but now you can see I've converted to liters. You can see it is 1.0. I divided 1000 divided by 1000. I got 1.0. And so you can see now the volume is in 1.0 instead of 1000. So it can be difficult to compare, for example, this 1.0 to 790, 7090 kilogram. But if we scale them both into comparable values, we can easily see how much one value is compared to the other. So there are different methods for scaling data, and in this course, guys, we shall use a method called standardization. The standardization, let me go to my code. The standardization formula method uses this formula. Perhaps, for example, let's say Z, and let me say Z. Then I'll assign it to, let's say, X. I'll explain everything in a few. X minus U, then over S. So now, guys, basically this. Let me explain this formula here. Guys, basically where you find Z, Z is the new value, and then X here is the original value, and then U is the mean, and then S is the standard deviation. And so if you take, for instance, weight column, if you take the weight column of the data set, here we have it. These are data sets. When you take you take the weight column, and then so the first value is 790, and the scale value will be, for example, it will be 790 minus 12. Actually, I said that the U is what? U is the mean, of which I calculated earlier. It is it is 1292.23. Now divide by, I said that the S is the standard deviation, of which it is at 238.74. You'll get something like a negative 2.1. So perhaps let me just show you everything in the code so that you may relate very well. Now, let me first of all clear this task. Now, guys, first of all, we need to import some modules here. So first of all, we're going to import pandas, and then the next thing we'll say from sklearn import linear underscore model, and then again from sklearn dot pre-processing. What is the spelling? Pre-processing. I think this is spelling. Let's say import standard scalar. A standard scalar like this, and then what is so here I'll say, for example, scale. Let me create a variable for scale. I say scale because that's quite a long name, so I want to create a variable for it. So scalar, I'll use this method here. Let me copy this function, and then I use it here as a method, so that in other instances I'll be using scale instead of standard scalar. Now let me try to import the data frame. So df, let me just use a variable df, then assign it to pandas dot read underscore csv, and then I'll pass here it was data dot csv, like this, and then let's also create our object with variable x, the comparable values, which is gonna be, let me assign it to df, but now targeting what? Targeting not really targeting weight and and volume. So it will be weight, weight, and then let's pass in another parameter called volume, weight and volume, and then now let's scale. We use this. Let me use let me say scale, scale dx, scale dx, scale dx. Scale dx, I'll assign it to perhaps, let me say scale, scale dot fit, scale dot fit, and then underscore transform like this. And then let's pass here, x. Remember this is capital X. Let me use a capital X here as our independent variable here. And then what I do here, guys, let me just say print. Print what? Let's say print a scaled x. Let me copy this variable name, and then let me pass, and then let me just try to run and see how the result will be. I don't know why it's not working. Let me run again, and then I guess you can see we have this kind of a data here. You can see the first one is at negative 2.10. So you can note that these are two values. The first one is negative 2.10 and whatever. Then the other one is negative 1.599. And so when you calculate with what I told you earlier, you get the same results. Now, so guys, basically the task in the multiple regression section of which we discussed was to predict the carbon dioxide emission from a car when you only knew its weight and volume. Now, when the dataset is scaled, you will have to use the scale when you predict the value. So, like let me just you copy these values, and then let me show you that. Let me just show you that. Let me paste it here, and then so x here x is our independent variable. Then let me create y for dependent variable. Here I'll say, for example, for instance, I'll say let me y assign it to df, and then here I'll assign it to carbon dioxide emission, CO, should be CO2 like this, and then scaled x. Scaled x, let me just use this one, and then let me do it. Let me just pass it here, and let me paste it there, and then now here let me also create another for the linear regression. For the regression, let me just call it regression. For regression, let me assign it to linear. Let me assign to linear underscore model. Let me assign it to linear underscore model. Linear underscore model dot linear regression. Linear regression method. Regression is a method, and then let's call it. And then let me say regret dot fit, and then I will pass here scaled dx, scaled x, scaled x, and then y, the dependent variable, and then I here say, for example, let me say scaled I'll assign it to scale. And then remember this scale, it is this scale is this one here, is this method. When I use scale, it is the same as this method above here, because I used it as a variable. Then I say transform, and then here I'll pass here my values. For example, let's use, for instance, 2300 kilograms, and then the volume is going to be 1.3 meter. Remember, the units are now in liters. Now, how do we predict? Let me first of all, let me create a variable for predicted CO2. So let me say predicted CO2. So sorry, should be CO. So predicted CO2. I'll assign it to regret, and then dot predict and then I'll pass here what I'll pass here, and that's scaled, should be scaled, and then which index? Let me use 0 here, for instance. Then what I do, let me say print, and then I'll pass here this variable. I hope my codes are okay here. Let me just pass here, and then let me try to run and see how it will look like. So guys, you can see we got 107.280. So guys, basically this is how you can do the prediction with the scaled with the scale method. Now let me talk about something else here, guys. Let me talk about the train test. And guys, basically this is very fundamental here. The train in the test model. So in machine learning, we create models to predict the outcomes of certain events. Like just in a few, I just show you how you can predict the CO2 emission. CO2 emission for a car when we knew the weight in the engine size. Now, to measure if the model is good enough, we can use the method called train test. So, what is train test? Train test is a method to measure the accuracy of your model. So it is called a train /test stock test because you split the data into two sets, a training set and a testing set. So 80% most of the time is for training, and then 20% is for testing. So you train the model using the train test, and then you test the model using the testing set. So remember, train the model means to create the model, and test the model means to test the accuracy of the model. So I want to let's start with the data set. Let's have our data set here, guys. I'm gonna use here. I'll use, for example, a data set that illustrates perhaps 100 customers in a shop in their shopping habits. I'll just use the Numpy random values to generate some random values for us. So in that case, guys, let me just import. Let me import Numpy. Import Numpy. Let me use it as a NP alias. And then also let me import Matplotlib because I might want to visualize. So let me say import matplotlib.pyplot. .pyplot is a PLT alias, and then PLT alias, and also let me say numpy .random.seed. I'll pass here too, and then now guys, let's create now our x and y axis values for the x and y axis. Then here I'll say, for example, let me say numpy np. Remember, you're using alias, and then let me use the numpy random, and then dot normal. I use a normal distribution normal. And normal, then I'll pass here these are values. Let me use a 3, 2, and then the values are gonna be 100. So then for x, not really, it should be y. Here I should have used here x, and then here the y, I'll assign it to np, np.random, np.random.normal again, and .normal. Then here I'll pass here perhaps 150, something like even 40. And then what else? I'll say for instance, I'll say let me use the 100 values in the same, but now here I'll divide with the values of x. I'll divide by with the x like this, and then now to visualize we use plt dot scatter, and then I'll pass here the x and y, and then how do we visualize? Basically, this one is for plotting the scatter, and then to visualize, we use plt.show a function. Let me try to run and see if it's working. Let me give it some. So basically, there's an error, right? So guys, you can see here, numpy is not defined. Oh, guys, I used it as alias. Let me just try to change here to np and see if it will work. Let me run. And then I guess you can see it works. So I forgot I should have used here the alias. And then I guess you can see now our plot, how our plot looks like. So basically the x-axis represent the number of minutes before making the purchase. And then at the y-axis here, this represent the amount of money spent on the purchase. Guys, basically let's now do it. Let's now split into the train and test. Let's split our data into the training set, of which should be a random selection of 80% of the original data, and then at the test should be the remaining 20%. So how do you do that? Now, so in that case, guys, here let me just copy the same codes so that now how do you split? Let me paste it here and then I try to zoom in a bit. So here I'll say, for example, train x. I'll assign it to x, and then here I'll use 80%. I'll use 80%, and then for y, training the y. Training the y, I'll use what? I'll use again the 80%, but now here I'll change here to y. Also here should be y, right? And then now and then now the other, this for training. Now for testing, I'll use test, for example, x. You can use another variable. Then let me assign it to x. And then here I'll give it 20%. Now for 20%, you just say 80. Then the column will be at the front like this, so that it is it is 80%. Remember that testing should be 20. If you have took the test train to be 80%, then the test automatically should be 20%. Also for test test underscore y, I'll assign it to a y, and then also should be 20%. So this is how you define 20%. No, so now guys, basically to display the scatter plot with the training set. For example, if you want to display the same scatter plot with the training set, you just do this. Use this code plt. Remember this is the alias for pyplot. Then I dot scatter. And then here I'll pass here the train and the train for x and the train for y. So I say train underscore x, and again train underscore y. Now let's try to visualize. Let's say a plt dot show like this. Let me try to run and see how it looks like. And then I guess you can see how it looks like. You can see how it looks. It looks like. Now for the test, if I want to display the test, let me zoom in again. If this one was for this one was for training. Now for test, you just say test x, and then here it is test y, and then when you run, again you'll find this kind of results. Remember, for testing we used the smaller number of data. We used only 20% of our data set. So this is how it looks like, guys. Now what does the data set look like? So in my opinion, guys, in my opinion, when I just look at the data set, yeah, it is I think this one is best fit for polynomial regression. Now to draw a line through the data points, we'll use the plot method of the Matplotlib module. Now let me just show you. Remember, I'm using the polynomial regression here in this case because based on how I look at this plot, then that's best fit for me to use it. Let me just do this. Let me just do this. Here I'll say what. Let me create my model variable. And then I'll pass here np, remember is the alias for numpy, then poly 1 dimensional poly 1d, and the poly 1d, and then I'll pass here numpy, that is np dot poly dot should be dot np dot polyfit like this, polyfit, and then here I'll pass here train underscore x, and then again train underscore y, train underscore y, then I'll pass here 4 perhaps, and then what else? I'll say, let me create now for the line. I'll call it, for example, my line, and then I'll assign it to np, the alias for numpy, then I'll linspace method here. I'll pass here what 0, 6, and then to 100, and then now guys, basically we are, let me just use first of all the train, also here train, I also train because I want to plot the original scatter for the train, for the train data, and then now for the line, now we use plot plt dot plot function, then I'll pass here my line, and also I'll pass here my model object, then I'll pass here my line, then to visualize we use the plt. So guys, basically you can see the results, or perhaps let me just try to change here to 1. Let me change here to 1 and see how it will look like. Let me use a 1 here, and then HP 150 here. Let me just try with this one, then see how the result will look like. So what I do, let me just try to run and see. So guys, you can see how the results it looks like, and then I guess you can tell that basically these results is best fit for this polynomial regression. This back up my suggestion that the set is fit for polynomial regression, even though it would give us some weird results if we try to predict the values outside the data set. For example, guys, the line indicates that a customer spending perhaps 6 minutes in the shop will make a purchase worth something like 200. That is probably a sign of overfitting, right? So but what about the R-squared score? The R-squared score is good indicator on how basically how well my data set is fitting the model. Let me talk about this R-squared or R2. It is written R2. is the same as r squared. So it measures the relationship between the x-axis and the y-axis, and the value ranges from 0 to 1, where 0 means there is no relationship, while 1 means there's a total relationship, or they are related completely. And so this learn model has a method called the R squared, of which I think we discussed earlier, that will help us find the relationship. Now in this case, guys, we would like to measure the relationship between the minutes of our customer stays perhaps in a shop and how much money they spend. And so how well does my training data fit in the polynomial regression? Let me just show you that. So basically, let me just use this data here. Let me just use this data. Let me copy. Then let me zoom in a bit. Then let me paste it here. And then now, guys, here I'll use, for example, for the R squared. Let me just use R2, and then here I'll assign it to the R squared score, R2 underscore score. Underscore score, and then here I'll say train and then underscore y, and again I'll pass here my model like this, and then of course I'll pass here also the train underscore x underscore x, and then let's try to execute and see how it look like the relationship. So r squared, when you run, let's try to check out and see how it will look like. R squared is not defined, right? R underscore score, it is not defined. So oh guys, basically I forgot here at the top. I should have imported the metric instead of I should have, because we are not visualizing, so we need to import the from sklearn dot metric, import that r2 underscore score like this, and I believe it will now work. Let me now try to run, and then guys, you can see we have a 0.7, like 0.799 when you round off. So basically the result is this one shows that it's a good relationship. There's a good relationship here. Now we have made a model that is okay, or good for prediction, at least when it comes to the training the data. So now we want to test the model with the testing data as well, and see if it gives us the same results. So in that case, guys, I'll just change here to I'll change here from train, I'll change here to test, right? Test and then also here I'll change here to test test, and then here what I do, let me just try to run again and see how it will look like. And then guys, you can see it is the result is 0.881. This shows that the model fits the testing set as well, and we are confident that we can use the model to predict the future results, because when it is let's say from 0.6 and above, we can use that model to predict our results. So like for example, if you want to predict something, like let's say for example, if you want to predict how much money will a customer spend if he or she stays in a shop for, let's say, about 5 minutes. So in that case, here the print function, I'll say for example, I pass here my model, then of course this card should be inside like this, and then guys, basically let me try to predict and see if it's true. Let me my model, it should be L here, L, Then let me run again, and then guys, you can see it is oh guys, basically I should have passed here. Oh sorry guys, I should have passed here. Now I should have passed here, for example 5. I should have passed here 5. Then let me run perhaps, because I said that 5 minutes. So guys, you can see it is 22.87. Let's try to compare when they stay at the shop like about 5 minutes. Let's try. So you can see when you reach here, then yeah guys, basically this one is definitely true. When they spend around 5 minutes, they are going to probably use what, 22 above dollars, 22 dollars, of which corresponds with the diagram you can see. So guys, let me now talk about the decision tree in machine learning. And guys, basically in this chapter, I'll show you how to make a decision tree, of course. And first of all, let's understand what is a decision tree. A decision tree is a flowchart that can help you make a decision based on the previous experience. So guys, basically I have some sample data set, and let me just show you perhaps. And you can see in this data set here that I've just created, a person will try to decide if he or she should go to the comedy show or not. So likely guys, basically in our example, a person has registered every time there was a comedy show. They have registered every time there's a comedy show. Now and also he has registered some information about the comedian, and also registered if she went or not. You can see we have this data set. You can see if they decide to go or not. So I have this kind of data sets. Now based on these data sets, Python can create a decision tree, and that can be used to decide if any new show are worth attending or not. So, but how does it work? First of all, let's try to read this CSV file, and yeah, I think guys, you can find this reference on the website. I don't know if I have this data there, and if not, I'll try to put it in the description, or otherwise you can just create your own. I think it's a good practice to create your own also, and test your data. Now, here, first of all, let's try to import this data. I place it at the desktop. It is test underscore data .csv file. Now, we use Pandas to read such files. So I'll say from import Pandas is a PDLS. Then I here to read this data frame. I'll say, for example, df the variable. Then I'll assign it to Pandas PD. Remember we are using alias, then a dot read underscore CSV file. Then at the path, remember it is at the same directory, so I'm gonna use data dot CSV like this, and then let's try to execute. Let's say print. Let's say print the df like this, and then let's try to run and see if, yeah, guys, you can see not really guys, it is test underscore data, sorry, it is test underscore data. Then let me run, and then guys, you can see we have this kind of a data set. So guys, now to make a decision tree, all the data has to be numeric. As you can see, the nationality that they go, these values are not numeric, so we have to convert the numeric values in this nationality, and that they go into numerical values. Now Pandas has a method called a map, and that takes a dictionary with information on how to convert the values. Like we can say, even for example, for instance, you can say, for example, UK, you can give it 0, and then USA, you can give it 1, then N, you can give it 2, and so forth. So it means that means convert the values of UK to 0, and then USA 1, and so forth. Let me just show you an example, guys. Let me just show you that for you to relate. So what I'll say, let me just use this new cell. Remember, when I use some values here, it can pull from these other cells. For example, let me just say, for example, D. then assign it to perhaps this dictionary here. UK. Remember we have UK here. I'll give it perhaps the value. I'll give it 0, and then USA. Remember USA is a string, so you have to use it in quotes. Then at the value I can give it perhaps 1, and then what is N? It was N here. I can give it even 2. So N, I'll give it what 2. And then I'm not really sure. First of all, the key, which is N. Then the value is what we give it 2. The value is what we give it 2. And then now at the DF, perhaps these are data frame. Remember we are pulling the data from above here, and then here I'll assign here. I'll pass here what? I'll pass here nationality. Perhaps nationality. It begins with a capital, right? Yeah, it begins with a capital. Nationality like this. And then what is let me do it. Let me assign here to let me assign it to these are new data from here to this DF to because I want to map here. I want to map it. So DF, then I'll assign it to, you know, nationality. Should be nationality, right? Let me pass here nationality, but now I'm gonna map here. So let me say dot map like this because I want to map it. And then here I'll use map here with D here to convert those values to numeric. I'll convert it to D. Then now for D, I'll assign it to a Boolean dictionary here. For example, let me say, for example, let me use, for example, yes. Now this one is for the go, no, don't go. So I'll say, for example, yes. Sorry, I'll say yes. For yes, remember I have only 2 values. We have yes and no. So for yes, I can give it even 1 if the person said to go to watch the comedy show. And then no, I'll assign it to 0 if they don't decide to go. Now how do I link them? So let me say, for example, let me say DF for go. Let me first of all check. Yeah, go, it's go. For go, I'll assign here to, and there's a new data, new values, new dictionary here. DF, and then I'll pass here go, and then I'll map it to what? To D. I'll map here to D, this value. And then what I do, guys, let me just try to print out DF. Let me say print a DF like this. Let me try to run and see if it's true. So guys, there's a type error here. Method object is not subscriptable. Let's check. Oh guys, basically I used a list here instead of a tuple. I should have used what? I should have used the tuple like this. Then let me pass here D. So guys, as you can see, it's not working. Let me do this. Let me try to just import the modules here. Let me just again import, because I think there's an error somewhere. So let me just say import. Let me say import pandas, and then let's read the data. So it is df, and then let me assign here to pandas read underscore CSV file, comma separated file. And then it is a test underscore data, I think, test underscore data. dot CSV, and then of course here should be what should be a dot. And then what I do, guys, let me just try to run again and see if it will work or not. Yeah, guys, you can see it's now working. You can see it's now working very, very nicely. So basically, this is how you can do it. This is how you can, convert those values here. Now, guys, basically then we have to separate basically the feature column. You have to separate the feature columns from the target, column. The feature columns are the columns that we try to predict from. Remember that. And then the target column is the column with the values we try to predict. Now, in this new cell, let me just use a new cell here. And then I guess in this case, I'll just say, for example, let me create a variable. Remember, it will pull data from above here. So I'll just say, let me say feature. And feature, I'll assign here to. Remember, I told you that a feature columns are the columns that we try to predict from. And then in this case, I'll target age. Age, we have the age column, right? You have age. And then we also have experience. I have experience, and then we also have rank. Rank, and then nationality also. Nationality is a string. Nationality, and then basically this is the feature column, and then basically y is gonna be the target. This go. Now we want to predict if the person will decide to go or not. So this is the the target column. So what do I do here? Say for example, let me create capital X for the independent variable here, and say df. Then I'll assign it to feature, or let me just add here the a so that it may be perfect. This is our independent variable, and then a dependent, let me assign here to df, and then should be go is a string go, and then let's say print. First of all, let's try to print and see x, and also see what let's say print y first of all. So let me just try to run and see. So guys, basically you can see how it looks like. So basically we have done what we have obtained these results. Now we can create the actual decision tree to fit in with our details. Now we'll start by importing the modules that we need. So guys, you can see first of all, you can see you have this data here. Now first of all, let's import our modules here, and this is a new cell so that we use the decision tree here. So we'll import first of all, or let me just copy this data. Let me just write again so that perhaps someone can understand what I'm doing. So let me say import pandas, and then I'll say from sklearn, import tree, and then also we're going to import the decision tree here from, let me say from sklearn dot tree import decision tree classifier, classifier. It should be classifier, right? Classifier. I think this is the spelling. Also, because I might want us to visualize, let me import Matplotlib. So let's say import Matplotlib dot pyplot. Let me use the alias for pyplot as a plt, and then now let me import this data. Let me just pull this data here. Let me just pull this data. Or before then, let me just copy it. Let me just copy this data. Let me just copy this data here. and then I do what let me paste it here. Perhaps let me try to reduce the spaces here, line space. And now we have this data, and then also let me copy this because I don't want to repeat myself. Let me copy, and then first of all, let me just reduce, and then here let me paste. So these are the features, a feature, and then the target is go. And then now guys, basically now that we have this data, let's now focus on the decision tree. So I'll say D3 for decision tree. D3, I'll assign here to decision tree class file. Let me just copy the method, and then let me just paste here. And then here I'll pass here what is a method, right? And then this one is I'm using D3 for decision tree classifier because it's a long name. I don't want to use that long name somewhere. And then here I'll say, for example, D3, and D3 again I'll assign here to D3. Remember this D3 that I'm using here is this it is this method here, but now the method itself now I'm converting to I'm using this D3 dot fit. I'm calling dot fit, then I'll pass here the independent variable x and a dependent variable y. Remember x is what? X is the features, then a y is the target. And then now here I'll say what I'll say so I'll say what is, let me say tree dot plot. I want to plot that decision tree plot, then underscore tree, then I'll pass here D3 comma, then a feature names. I'll assign here to features. We use the variable features like this. Let me just try to run and see how it will look like. Oh guys, basically I think for it to work, I think we should have imported the module itself. We should have imported the model. I forgot. Let me just do that for it to work well. Let me just copy this code to import the data set, and then let me use it here somewhere. I forgot this one. Now let me try to run, and then guys, basically it is working, right? It is working very well. And then guys, basically you can see this the decision tree here. It's now working super fine. Now let me try to explain this data, this decision tree here. Now the decision tree uses your earlier decision to calculate the odds for you to wanting to go to see the comedian or not. And so let us read the different aspect of this decision tree. Now you can see we have a rank. Let's begin with the rank here at the top. Now rank, you can see it is less than or equal to 6.5, meaning that every comedian with a rank of 6.5 or lower will follow the true arrow. Will follow the true arrow to basically to the left, and the rest will follow to the false arrow to the right. And then we also have the Gini there, which is 0.497. This one refers to the quality of the split, and it's always a number between 0.0 and 0.5 in most cases, where 0 will mean that all the samples got the same results. And then we also have the sample here, right? We have sample 13, and then that means this 13 here. 13 means basically the comedians left at this point in the decision, which is all the same since it is the first step. Now the value, you can see we have a value 6 and 7. This means that that 13 comedians, 6 will go or will get a no, and the 7 will get a a go. So perhaps let me talk more about this Gini here. So basically there are many ways to split the samples. We use the Gini method in in this example, guys. Basically, the gene method uses the formula 1 minus into x over n squared minus y over n squared, where perhaps let me just write somewhere so that you can relate. So gene, it uses this formula 1 minus into x over n, and then I don't know how to put the superscript here, but let me add here 2, but I just assume it is a superscript here, and then a minus into y over n, and then a superscript 2. I'll explain everything. Superscript 2, where is it? 2 actually squared. So guys, basically let me try to explain. Now x is the number of the positive answers, which is to go, and then n is the number of the samples, and then y is the number of the negative answers, that is no, which gives the calculation. For instance, if you have perhaps x to be 7, then n to be 13, then squared, and then minus y perhaps to be 6, and then n is the number of people, it is 13. Then when you square, you will find something like 4.975, of which you got here. So basically, in a nutshell, that's how you calculate the gene. Now the next step contains what? This next step contains two boxes here. It contains two boxes, one for the comedian with the rank of 6. One contains the one for rank with 6.5 or lower, and then the other box is with the rest. So Gini, you can see it is what? 5 comedians end here. 5 comedians end here. You can see we have 5. So the Gini here, it is 0.0, right? Means that all the samples got the same results. That's good. And then you can see now the samples here are 5. Means that there are 5 comedians left in this branch, and 5 comedians with at least, let's say, a rank of 6. 6.5 or lower. Remember what we discussed earlier here while I told you about the rank, and then now they have shifted to the left here. So and then the value you can see here, it is 5, and then a 0, meaning that a 5 will get a no. 5 will get a no, then a 0 will get what? Will get a go. And then guys, I can see here on the right we have the false. I said that the false will go in this other section, and then we have 80 comedians. You can see sample is 80 comedians, which will continue. Now in the nationality for less than or equal to 0.5, it will mean that the comedian with a nationality value of less than perhaps 0.5 will follow the arrow to the left, and then which means that everyone from it will mean that everyone from the UK, and then the arrow will follow to the right. Gini, you can see it is what? Gini is 0.219. 0.29 means that about 22 of the samples will go in one direction. And then remember I told you how to calculate this. And then samples, for example, samples 8, there are 8, means that there are 8 comedians left in this branch. And remember, 8 comedians these are 8 comedians with a rank of higher than 6.5. These are the ones which are in the right. And then the value is 1, and then 17 means that basically that of these 8 comedians, one will go, and then 7 will not go. Actually, one will get a no, and then 7 will get will get a go. For example, because we are not plotting, let me just remove this stuff here. So D3 classifier, let me just minimize this section here. Then I guess here I'll say what? Let me say print. Print. Then I'll print what? D3 dot predict, and then I'll pass here what? I'll pass here these two-dimension data here, 40, and then I'll say, for example, 10, 7, and 1, perhaps 1, and then yeah, I think it is good. Then now here again also I'll want to do it. I'll want to print, let's say print, then I into quotes I'll say what, perhaps the first one can be the first index, let me say 1, and then I'll say means what? Means go, means go. Means go. Remember, these quotes should be here at the end. These two quotes like this. Yeah, like that. And then what is let me just execute something else. Let me say 0 will mean that no. 0 will mean no. And then let me try to check this code if they are okay. D3 go and then I think everything is fine. Let me try to run and see how it looks like. So guys, you can see how it looks like. So basically this is how you can go about that. And what about if the comment rank was 6? So in that case, let me try to change here to perhaps 6, rank to be 6, and then let me just try to run, and then I can see the 1 will mean that it goes, and then 0 will mean that there's a no. So basically it is based on the probability of an outcome, and that the answer will vary in most cases. Now this is all about the decision triggers, and I think you've understood the concept there. And so guys, the other thing that I want us to learn here in machine learning is the confusion matrix. And this one is a table that is used in classification of problems to assess where the errors in the model were made. And so the row will represent the actual classes the outcome should have, while the columns will represent the prediction we have that we have made. Basically using this table, it is easy to see which prediction are wrong and which ones are right. So let's begin by first creating the confusion matrix. And our confusion matrix can be created by prediction made from the logistic regression. Basically for now we'll generate the actual and predicted values using Numpy. We will just use Numpy, but we shall randomize our values here. We'll generate our random values. So first of all, to import Numpy, I think by now you understand. So you just say import Numpy. Let me try to zoom in. Numpy, and then here the actual, let me say actual values. I'll assign here to numpy.random random.binomial and then I'll pass here 0.9. Size is gonna be size. I can give it let me give it 1000. And then for predicted, let me just copy this one, and then paste there. Then this one is gonna be the values for the prediction. Let's say predicted, and then here is gonna be still binomial. In order to create the confusion matrix, we need to import also another the matrix from the sklearn model. So here at the top we can do what we can say from sklearn. From sklearn, I import matrix like this, and then once the matrix is imported, we can use the confusion matrix in our actual predicted values. How do we do that? So here at the bottom, I can say, for example, confusion. Let me just create a variable for confusion matrix. Or should I use a variable? Let me just let me just be descriptive here. Let me use a camel case here. Snake case. Let me say confusion underscore matrix. Matrix. I think this is spelling. Then let me assign here to matrix dot confusion matrix like this, and then I'll pass here actual and the predicted. Now guys, basically to create a more interpretable visual display, we need also to convert the table into the confusion matrix display. How do we do that? And say, for example, say confusion, let me use here a variable. Let me just say, for example, cm confusion matrix display. Display, I'll assign here to a matrix dot confusion matrix display, and then I'll pass here confusion matrix, that variable confusion underscore matrix like this, my confusion matrix, and then again I'll assign here to confusion underscore matrix, and then also display display underscore labels. I'll assign here to these list of values, boolean values. They're gonna be false and true, respectively. So so what do I do next? Let me now to visualize the display. We require to import the Matplotlib also. So we have to say import matplotlib.pyplot. Let me use the alias for plt. For Matplotlib, it is a plt. And then finally, to display the plot, we can use the function plot and show from the pyplot. Perhaps let me just create here a new space, and then let me say cm underscore display display.plot function to plot. Then to visualize, we'll say what plt dot show like this, and then let's try to do it, to run and see how it looks like. So let me just try to run and see how it looks like. Oh, it is it should be matrix, right? It should be matrix. I should have used here matrix. I used it should be matrix like this. I think confusion matrix. I think this is the spelling right. And then also where here it is confusion matrix. I think it's right. So let me try to run again and see if it will work out all right. So yeah, guys, it's working very fine. That's very perfect. You can see how it looks like here. So perhaps let me try to explain this stuff here. The confusion matrix created has 4 quadrants, as you can see. we have the true negative. This is top left. The true negative is top left here. This is the true the true negative, and then at the false positive, it is at the top right here, the true positive. And then the false negative, guys, it's at the bottom left quadrant here, as you can see. And then the true positive is here at the bottom right quadrant, as you can see. So basically, let me try to explain what these stuff mean. The true means the values were accurately predicted. False means that there was an error, or basically there was a wrong prediction. Now that we have made a confusion matrix, and we can calculate the different measures to quantify the quality of the model, let's first look at the accuracy. Let's try to get the accuracy. Before then, let me talk about the created matrix here. Now, basically, the matrix provides us with many useful metrics that help us to evaluate the classification model. Now, the different measures include here accuracy, precision, sensitivity, or sometimes the recall, specificity, and then also the F-score. Perhaps accuracy. Remember, accuracy measures how often the model is correct. And then let me just show you guys so that you may understand everything here. And so, for example, how to measure the accuracy here in this case. So what I'll do, let me have these codes. Let me have these codes. Then let me paste it here. Let me paste it here, and then of course in this case we don't need a lot of we don't need the visualization and such stuff. So let me just remove this stuff, and then so I'll do it. I'll have only also here I should have deleted, right? Let me just delete this stuff. Also let me just delete everything. Then here let me create a variable for accuracy. Let me just say accuracy. Let me zoom in. Accuracy. I'll assign here to matrix dot accuracy underscore score. Then I'll pass here actual and what predicted. So basically this accuracy underscore score method will help us to obtain what the accuracy here. So let me say print accuracy. Let me try to run and see if it will. So basically this is how you can obtain the accuracy. But how do you calculate the precision? That is true positive of divide by the true positive plus false positive. So precision does not evaluate the correctly predicted negative cases. So guys, basically what I do here, so to obtain that, just I change from accuracy, I'll obtain I just type here precision, and then this precision will help us to get percent, to get what percent is positive, is truly positive. So let me just try to run, and then I guess you can see we have the values there. So this is how you can obtain that. And then for sensitivity, sometimes called recall, this one is basically of all the positive cases, this one tries to find what percentage are they predicted positive. So sensitivity, sometimes called a recall, measures how good the model is at predicting positives. So this means it looks at a true positive and a false negative, which are positive that have been incorrectly predicted as negative. So how do we calculate it? We take true positive over true positive plus false negative. So sensitivity is good at understanding how well the model predicts something is positive. So in that case, guys, here change here from precision, change here to recall, recall, and then I can see in our case it's very good. You can see it's 0.9. So guys, the other item here that perhaps I talk about is the specificity. So this one describes how well a model is it at predicting the negative results. So basically specificity is similar to sensitivity, but it looks at it from the perspective of negative results. Remember sensitivity is at the positive. Now, how do we calculate? We take the true negative over the true negative, plus the positive. So this is how you obtain. Since it's just opposite of recall, we use the recall underscore function, taking the positive the opposite label. So in that case, guys, I just use the recall, but now we add in here post label. We just add in what we just take this opposite label. So label, what's the spelling for label? And assign here to 0, and then let me run, and then guys, you can see how it looks like. So and then for f-score, this is the harmonic mean of precision and the sensitivity. So it considers both the false positive and the false negative cases, and it is good at embarrassed data sets. And so how does it calculate? This one should be 2 multiplied by into precision multiplied by sensitivity of perhaps let me just try to write for you because this kind of complicated a bit. So it is 2 multiplied by, and then we pass here we pass here first of all the precision. It is precision multiplied by sensitivity, and then remember I showed you how you can do it, how you can calculate the precision and sensitivity, and then now you divide by it, and then you divide by the actually you divide by precision plus sensitivity. So basically this is the formula. This is the formula on how you can calculate the f-score. But now here with the formula here with a Python here to code, it's quite easy. Just pass here what and just pass here f1 score, and then it's gonna do everything for you. And then you can see the value is 0.0947867298578199. So this is how you can do that. And of course you can do the shorthand for everything here, guys, but I don't want to go into that. But guys, in a nutshell, this is all about what it is all about, the confusion matrix. So guys, the other thing that I want us to talk about is the hierarchical clustering. And basically hierarchical clustering is an unsupervised learning method for clustering data points. So the algorithm builds clusters by measuring the dissimilarities between data. So unsupervised learning means that a model does not have to be trained, and I would not need a target variable. So basically this method can be used on any data to visualize and interpret the relationship between individual data points. So in this case, guys, here we'll use the hierarchical clustering to group data points and visualize the clusters using both the dendrogram and also the scatter. So basically, how does it work? So basically, we'll use agglomerative clustering, a type of hierarchical clustering that follows bottom-up approach. So we begin by treating each data point as its own cluster. Then we join clusters together that have the shortest distance between them to create larger clusters. So this step is repeated until one larger cluster is formed containing all the data points. So basically hierarchical clustering requires us to decide on both distance and the linkage method. So we'll use the Euclidean distance and the word linkage method, which attempts to minimize the variance between them. But let's begin by first starting to visualize some of the data points. So I'll create here some data points here, guys. Perhaps let me say, let me just say, so let me just delete these stuffs, and then perhaps let me just try to zoom in a bit. And then here first of all, let's import Numpy, because I'll kind of use the so let me say I'll use the Numpy here. Let me say import Numpy is what np alias, and then also let me say import Matplotlib .pyplot, and .pyplot is a plt alias. So x I'll assign here to this list. Perhaps let me say 4, 5, 10, 4, and then 3, perhaps 3, 11, and then 14, and then 6, perhaps 10, and then 12, and this is the x. And then for y I'll assign here to this list 21, 19, 24, 17, 16, 25, perhaps 25, and then 25, and then 24, and then 22, then 21, also 21. Now how do we visualize? Let's say plt dot scatter, then I will pass here x and also y, x and y, and then plt dot show to visualize, plt dot show, and then first of all, let's try to let me run and see how it looks like. Let me zoom out a bit. So guys, now we compute the word linkage using the Euclidean distance, and visualize it using the dendrogram. So in that case, guys, we have to import some other modules here. Like I'll have to import also from SciPy. Let me say from SciPy dot cluster, from SciPy dot cluster dot hierarchical basically hierarchy import dendrogram and also linkage now we have this data here. So now perhaps here let me also add here some data. Let me create a variable data and then assign here to the list. I'll pass here zip, and then also I'll pass here x and y. Now for linkage, I'll say for example linkage. First of all, let me create some space there. So I'll say for example linkage underscore data. I'll assign here to linkage. I'll assign here to linkage, then I'll pass here data. Remember, data is a variable for this stuff, is a container for this values here. And then also method is what? Method is word. This is word linkage that we are trying to use here. And then the metric. The metric here is gonna be Euclidean. What's the spelling? Euclidean like this. And then for the dendrogram, let me say dendrogram. Dendrogram. I'll pass here what? Linkage. I'll pass here linkage, linkage like this, linkage underscore data, linkage underscore data like that, and then of course, what do I do? How to visualize guys? I will use this stuff. So I'm hoping my codes are right. Code. Let me try to run and see how it looks like. So cannot import name dendrogram from SciPy. So guys, basically should be dendrogram, should be dendro. I forgot, should be dendrogram. Where else? Dendrogram also here. Dendrogram, I think. Let me try to run again and see. So name linkage data is not defined. Is not defined. So linkage like this. Linkage, or should be data, right? Should be data. I forgot. Should be data. Okay. Then let me try to run. Yeah, guys. Basically, you can see how it looks like. So here we do the same thing with the pyplot scikit, learn library. Then we shall visualize on the two-dimensional plot. So to go about that, I'll have to do it. I have to change here some code here. So let me just copy the codes here and then I use it in some other cases. Let me just to another cell perhaps. Let me just paste it there. And then for in that case, guys, I will have to import here another module called from sklearn cluster. Import. I'll say import agglomerative clustering like this, clustering. And then here perhaps let me just change here the codes, or let me just delete everything so that let me just create a variable here. Perhaps let me just say hierarchical underscore clustering cluster I'll assign here to. Let me copy this method because it's kind of long, and then let me just pass it there, and then is a method, of course, and then I'm gonna pass here some other arguments here. So n underscore cluster clusters, I'll assign here to perhaps 2. Then affinity I'll assign here to Euclidean. Euclidean like this, should be somewhere C. Euclidean like this. Then the language is gonna be word. So in linkage here is gonna be, we're gonna use word like this. And then what do I do? First of all here, let's say a PLT, because I want to plot also the scatter here. PLT.scatter. PLT.scatter is spelling for scatter. I think it's double T. And then I'll pass here X, and then I'll pass here Y also. Then I foresee labels, so I'll pass here there. I want to have the labels displayed. So labels like this. Then let me try to run and see if it will work. I don't. So basically, there's an error. Agglomerative clustering, or basically we used here a wrong name. Agglomerative. So okay, so basically we used here a wrong name. So it should be agglomerative clustering. But I think it's just okay, don't know. Agglomerative clustering, agglomerative, or the spelling is wrong. Agglomerative, sklearn. Oh, guys, basically here we should have used here sklearn, not SciPy. Should be sklearn. Now this is the issue with the copy pasting. You don't change everything. You don't you know, you import the problems from the other sets to these ones. So let me try to run and see if it will work out. Yeah, guys, you can see it. The labels are not defined. Again, I used the wrong spelling for label. It should be label like this, labels, I think. And then guys, when you run, then you'll obtain what? You'll obtain these stars here. So it will look like this. So guys, in a nutshell, this is all about the hierarchical clustering. So guys, let me now talk about logistic regression. It's a very important aspect here in machine learning. And logistic regression aims to solve classification problems. It does this by predicting categorical outcomes, unlike a linear regression that predicts continuous outcome. Now, in the simplest case, there are two outcomes, which is called a binomial. An example of which is predicting if a tumor is malignant or a benign. Other cases have more than two outcomes to classify. Basically, in this case, it is called a multinomial. A common example for multinomial logistic regression will be predicting, for example, the class of an iris flower between three different species. So guys, basically in this case, what I'm going to show you will be using the basic logistic regression to predict a binomial variable. This means it has only two possible outcomes. First of all, how does it work? We are starting by importing the Numpy. We are going to use Numpy here. So let me create a new cell here, and then I try to import the module. It is Numpy, and then so guys, basically we need also to store the independent variable perhaps in X, and then we'll store also the dependent variable in Y. So how do you do that? So first of all, let me create X, capital X. You remember this one to be independent variable. Remember, this X will represent the size of a tumor. For example, in centimeter, I'm gonna use here centimeter in my case. So I'll assume, let me use NumPy. Then it's gonna be an array, and then in this array list, I'm gonna pass here some values. Remember the units are in centimeter, so 3.78. Also perhaps 2.44, 2.0909, and then 0.14, and then 1.72, and then 1.65, and then 4. Let me use a 4.92 like this, and then also 4.37, 4.37, and then 4.4. Let me say 4.96, right? Let me use 96, and then another one, let me use 4.52, 4.52, then 3.69, and then another one is 5.88, 5.88 like this. And then so guys, basically this one I'm assuming it represents the size of a tumor in centimeters. Now guys, a quick one. Remember, these are independent variable has to be reshaped into a column from a row for basically for the logistic regression function to work. And then let's also create Y. Then this one is going to be independent variable, of which is going to represent whether or not the tumor is cancerous or not. Remember, 0 perhaps is going to mean that for no, it will mean no, and then 1 is going to be yes, which will mean that the tumor is cancerous. So what I do, let me create the independent variable here. For example, let me say Y. Then I'll assign here to again NumPy. Also NumPy.array. numpy array, and then in this array list, guys, I'll pass here, for example, I'll pass here 0 0 0 0 0 0 0 0 0, and then let me pass here also 1 1 1 1 1 1 1 1. How many are they? They should be something like, let me count 1 2 3 4 5 6 7 8 9 10 11 12. And then now here it is 1 2 3 4 5 6 7 8 9 10 11 12. I think they are okay, right? So now, guys, basically we use a method from the sklearn module, so we'll have to import the module itself. So here at the top, let me just say from sklearn, import a linear underscore model like this. Now basically a linear underscore model, then here say from basically from the sklearn model, we'll use the logistic regression method to create logistic regression object. So this object has a method called fit that takes the independent and the dependent values as a parameters and fills the regression object with the data that describes the relationship. So how do we do that? So I'll say, let me create a variable for that. Let me just say for logistic regression, let me use a variable log r, and then I'll assign here to linear underscore model, and then logistic regression. Let me do it. Let me just say logistic regression, right? Regression, and then is a method, and then now we have to feed. We now have to use here the fit that takes the independent and the dependent values as parameters and fills the regression object with the data that describe their relationship. So first of all, the log r, logistic regression log r, then dot fit, then our dependent variable is x, and then y, our dependent variable. So now, guys, now we have a logistic regression object that is ready to whether a tumor is cancerous based on the tumor size. So, guys, basically, how do we predict? Let's try to predict if if a tumor is cancerous where perhaps the size is perhaps is 3.46 or whatever. So in that case, guys, I'll have to use these. First of all, let me create a variable predicted. Should be predicted. predicted. Then I'll assign here to log r, and then let me say dot predict. Predict. Then here I'll pass here what? I'll pass here numpy. I'll pass here numpy dot array. I'll pass here numpy dot array, and then I'll pass here these values. Perhaps I say that I want to use I want to obtain the size of 3.5 3.46, basically just to check if the tumor is cancerous. So I'll say 3.46, perhaps 46, and then also, guys, I say that we have to reshape it. So I'll say dot reshape method, then I'll reshape here to -1, and then +1 here like this. And then guys, basically how do we do let me try to execute. Let me say print, and then I'll pass here what? I'll pass here predicted. and we want to check if that tumor is cancerous. You can see the size is 3.46, so we want to predict if it's cancerous or not. So let me try to run and see. First of all, basically there's an error, right? Let me find the description of the error. Expected a 2D array, gotten the one-dimensional array instead. I should have reshaped. So guys, basically I forgot I should have reshaped these ones. This one to be so let me say dot reshape. I'll reshape it. I'll reshape here to -1 and +1 again here, and then I'll try and see if it will work out or not. Let me just try to run, and then as you can see it is 0. It is 0 meaning that it's not cancerous. It means that it's not cancerous. We have predicted that the tumor with a size of 3.46 will not be cancerous. Now let me talk about the coefficient. Now, in logistic regression, the coefficient is the expected change in log odds of having the outcome per unit change in that x, that independent variable. So this does not have the most intuitive understanding. So let's use it to create something that makes more sense or odds. So I'll use just the same. I'll just use the same values, right? Let me just use the same values. But here, guys, I'll do it. After this one, log r here, and then also after this, let me just delete this stuff. Then let me just say log underscore odds. Log I'll assign here to log r dot coefficient dot coef it ends with an underscores like this, and then odds like this. And then what I do odds, then I'll assign here to the numpy dot exp, and I'll pass here what log underscore odds. So here at the terminal, the print function will pass here what? Will pass here odds. Will pass here odds. Of course, guys, here should be in a new line of cell. So guys, basically what I do, let me just try to run and see if it will work out. And then guys, you can see we have 4.035416 5 7s. So this tells us that the size of the tumor increases by 1 millimeter, the odds of it being tumor increases by 4 times. You can see this when you run off, it's like 4 times. Now perhaps let me talk about the probability. Now the probability and intercept values can be used to find the probability that each tumor is cancerous. So we have to create a function that uses the model's coefficient and the intercept values to return a new value. So these are new value represent the probability that given observation is a tumor. And so like I'll create here let me just code for you. Let me just write here some code here so that for us to understand the much better, I'll use here function. And so and then I'll explain, of course. Let me say div, then I'll assign here to log it to probability to prob. Any function name you can use another name. Then for example, let me say log r. I'll pass here log r, then also the independent variable x, and then indentation of course must be there. Then here pass here, I'll say log underscore odds. I'll assign here to log r dot coef like this, and then I'll multiply. We use asterisk to multiply the independent variable, and then plus the log basically the log r dot intercept underscore the intercept underscore, and then also let me just pass here odds, and then I'll assign here to numpy numpy dot exp, and then what else? Let me pass here log underscore odds like this, odds, and then for probability is gonna be probability, and then let me assign here to odds over into, I'll try to explain, guys, just hold in there, plus odds, and then let's say return, I'll say return probability. I said probability. What's the spelling? It is probability, right? Probability, and then here the print function will pass here this variable. We'll call this function here. So here we have to call it. Then pass in what these are per arguments, log r, and then the independent variable. So guys, basically now let's try to run and see how it will look like. Let me just try to run, and then I guess you can see the results here. Let me try to explain, guys. These are the first one was what? It was 3.78, and then I guess you can see the probability that a tumor with the size of 3.78 centimeters counters is 60.1. When you multiply by 100, it will be 60.1, and then 2.44. Basically the probability with the size of 2.44, it is 1.9, and so forth. So basically this is how you can do it. This is how you can predict with the logistic regression. And guys, basically this is in a nutshell all about the logistic regression. So guys, the other thing that I want us to talk about here is the grid search. And the majority of machine learning models contains parameters that can be adjusted to vary how the model learn. For example, the logistic regression model from the sklearn has a parameter called C that controls regularization, which affects the complexity of the model. How do we pick the best value for C? The best value is dependent on the data used to train the model. But how does it work? One method is to try out values and then pick the value that gives the best score. This technique is known as the grid search. So if we head to select the values for 2 or more parameters, we would evaluate all combination of the sets of the values, thus forming a grid of values. So, guys, before I show you an example, it's also good to know what the parameter we are changing does. Remember, the higher value of C tells the model the training data resembles the real world information. Place a greater weight on the training data, while the lower value of C will do the opposite. Now, guys, basically, perhaps let me talk about how you can use default parameters. First of all, let's see what kind of results we can generate without a grid search using the base parameters. Basically, to get started, we must also first load the datasets that we'll be working on. And so what I do, guys, here, remember these are just inbuilt data. So what I do here, guys, let me just say from sklearn import datasets, and then so for iris, I'm gonna remember these sklearn, it has these are datasets by default. You don't have to have your own datasets. You can use it to learn. So for example, let's create for iris. Change the iris to these datasets. Basically, like we give the variable for iris to datasets, datasets basically load underscore iris. Remember now this iris that we've used here is now the container for this function and the method load iris load underscore iris method. So guys, now that we have this data, now next, in order to create the model, we must have a set of independent and variables, and of that is x, capital X, and also the dependent variable y. So how do we do that? So let's say x, I'll assign it to iris. Remember, iris is the container for this function in the method here. So I'll say iris it is data, and then remember this is the independent variable, and then for dependent I'll assign it to iris, and then I'll assign it to now target. Now guys, basically we will load the logistic model for classifying the iris. So in that case we have to import this method called logistic regression from sklearn linear model. So I say from sklearn dot linear underscore model import logistic regression. So guys, are basically creating the model, setting the max height to a higher value to ensure that the model finds results. So keep in mind that the default value for C in a logistic regression model is 1. So we'll compare this later. I'll show you later. But in this example that I want to show you here, we'll look at the iris dataset and try to train them basically the model with the varying values for C in logistic regression. So guys, basically let me do this now. Let me now create a variable pass. Let me call it logit item. Then I'll assign it to logistic regression method. Then I'll pass this parameter here, max underscore item. I'll assign here to perhaps some higher values are given. Even 10,000 should be 10,000. Let me just use 10,000. I think these are 10,000. So remember, this logit is the container for this method. We'll carry this method here. So after we create the model, we must fit the model to the data. So first of all, let me do this. Let me just say to fit it, I'll say print. And let me just call it logit.fit the independent variable x and the dependent variable y. And then to evaluate the model, you have to run the basically to evaluate the model, we run the score method here. Let me use another print function here. Let's say print, and then here I'll pass in a logit. Remember, logit is this container for these values. Logit, then let me say score, and then I'll pass here also the independent and the dependent variable. So guys, basically let me try to run and see how it looks like. Yeah guys, basically you can see now the logistic regression, the max height to being 1000, you can see it is 9.77. Now guys, basically with the default setting of C being 1, we achieved this score of 0.97. Remember, by default it is 1. So we achieved this score 0.97333 to all the way to 4. And so how do we implement the grid search? We'll follow the same steps that we've used here, except this time we'll set a range of values for C. Now, knowing which values to set for the searched parameters will make a combination of domain knowledge and practice. So since the default value for C is 1, we will set a range of values surrounding it. So I'll say for example, let me create here, for example, let me do it. Let me just create a variable for C here. Let me just create C. Then I'll assign here to the range of values 0.25 perhaps, 0.5 perhaps, and also 0.75, 1 perhaps, 1.125, 125, basically should be 1, then 25 here, 25 like this, and then what is 1.5, 1.5, and then also 1.75, and then 2. So here should be 2.5, 2.5, then 0.5, 0.75, and then 1.25, 1.5, 1.25, 2.5 or 7.5. It should be 7.5, 7.5, and then 2 at last. And so next we will create a loop for basically to change out the values for C and evaluate model in each change. So say for example, let's first of all create an empty list to store the score within. So I'll do this. I'll say for example scores. I can use another variable. Let me assign it to the empty list. And then now guys, now to change the values of C, we must loop over the range of values and update the parameters each time. So guys, in that case, let's do this. Let me say for choice in C, for choice in C, I'll pass here logit. I'll pass here logit dot set and dot set underscore params. Then I'll assign here to C choice, and then also I'll do what I say logit. I'll fit the values with the fit method. Then I pass in the independent and the dependent variables, and then for scores, I say scores dot append, and then what I do here, I'll pass here logit dot score of both independent and the dependent variable y. And then now guys, basically with the scores stored in this in a list, we can evaluate what best choice for C is. So by passing let me just delete this this print function, and then here I'll pass I'll pass here scores. I'll pass here scores, and then what I do, let me try to run and see how it looks like. So guys, I basically obtain this data here. So so guys, let me try to explain. We can see that the lower value of C performed worse than the base parameter of perhaps 1. However, as we increase the value of C to 1.75, and then what the model experienced an increased accuracy. You can see it ranges from 0.96, and then you can see highest is 0.99. When you round off, it will be 0.99. So guys, basically this is on how you can do that. So basically with these results, it seems that increasing C beyond this amount does not help to increase the model accuracy. So guys, the other thing that I want us to talk about here is the categorical data. Now, when your data has categories represented by strings, it will be difficult to use them to train the machine learning models, which often use numeric data only, it accepts only numeric data. So instead of ignoring the categorical data and excluding the information from our model, you can transform the data so that it can be used in your models. So and so guys, basically for the multiple regression, I think I had some data sets there, and of which I'm gonna use it here also. And so guys, first of all, let me just show you. So guys, if I remember, I'll add the data set in the description, the data in the description. I have data in my, you can see I have data here called data.csv here, data.csv, and then I have some values inside it. So I'm going to use this data, and then guys, basically, let me just first of all import. But remember, in the multiple regression section, we tried to predict the carbon dioxide emission based on the volume of the engine and the weight of the car, but we excluded information about the car brand and the model. So the information about the car brand or the car model might help us make a better prediction of the emitted carbon dioxide. So first of all, perhaps let me talk about one-hot encoding. So we cannot make use of a car or a model column in our data since they are not, numeric. Perhaps, guys, let me just try to import the data to load the data so that you can see what I'm talking about. Let me say import. Import Pandas is PD alias, and then perhaps let me say cars, and then let me assign it to PD dot read underscore CSV. Then here I'll pass here data dot CSV, comma separated file CSV, and then here perhaps let me just try to execute. Let me say print, and then I'll pass here cars, of course, to string here method, and then let me just try to run and see how it looks like. So so guys, basically there's an error here. It should be 2 underscore string 2 underscore string like this method for it to work. Let me try to run, and then guys, you can see our data sets now. So guys, you can see now the car and the model. They are not numeric, right? So they are not numeric. Now, basically, in the multiple regression, guys, as I said earlier, we tried to predict the carbon dioxide emission based on the volume, or basically on the car volume of the engine and also the weight of the car. But we excluded the information about the car type and the model. And so, basically, the information about the car brand or the car model might help us, make a better prediction of the carbon dioxide emission. Perhaps let me touch on one-hot encoding. We cannot make use of car or a model column in our data since they are not numeric, right? They are strings, right? So a linear relationship between a categorical variable, that is car or model, and a numeric variable for carbon dioxide cannot be determined. Now, to fix these issues, we must have a numeric representation of the categorical variable. One way to do this is to have column representing a group in the category. So for each column, the value will be perhaps either 1 or a 0, where 1 represents the inclusion of the group and a 0 represents the exclusion. So this transformation is called one-hot encoding. You do not have to do this manually. Python Pandas model has a function that is called get underscore dummies, which does the one-hot encoding. So remember, I have a course on Pandas, a full course on Pandas. If you find time, just go there and learn all about Pandas. Then you'll understand every concept here. So also you can go to the website and you can find the reference there. So so on the same note, guys, let me just try to first of all, let me copy the values, the data here, and then what I do, let me just paste it there, and And then so let me show you guys how you can do that. So say PD, because I used this as a PD alias PD, PD, then I'll say dot get underscore dummies, dummies like this, and then I'll pass here cars, and then I'll target the car category. Should be now car, should be car like this, and then now so for one hot encoding, I'll say one hot encoding like this. Okay, one hot encoding like this, and then let's try to run and see. And so I should be for cars. So okay, one hot encoding, then a cars, because we're tagging now the cars, and then what we do, one hot encoding for cars, I forgot to give it a variable. I should have let me just create a variable for that. I'll say, for example, one hot encoding underscore cars. I'll assign here to pd dot get dummies cars, and then let me just try to run again and see how it looks like. Still it gives the error, right? Oh guys, basically here I should have used not, I should have removed this one. Then let me run. Yeah, so as you can see now, you have other columns were created. A column was created for every car brand in the column, in the car column section. And so you can see how it looks like. And then now guys, basically let's try to predict the carbon dioxide. We can use the information alongside the volume and the weight to predict the carbon dioxide. So basically, to combine the information, we can use the concat function from Pandas. Basically, first we need to import the basically a couple of modules, which we will use to we'll start by importing Pandas. Let me just do this. Let me copy these values. I don't know if you can see. Let me try to zoom in, because even me I can't see better, and I'm on the screen. And then here guys, let me first of all I'll use what this PD, and then to load the CSV file we use this command, and then the second one allows us to create the dummy variable, of which is here. And then the next we must select the independent and x, basically the independent variable of which we can use it like x, and then get the dummy variable column wise, and also store the independent variable in y. In that case, guys, I'll just say for independent variable, I say I use capital X, and then I'll assign it to pandas. Pandas.concat to concatenate or to combine to concat, and then I'll pass here cars, and then volume is a string, so volume, and then also weight, weight, and then also I'll pass here weight. I'll pass here also one hot encoding for cars, one hot encoding underscore cars. Remember that variable cars, and then another parameter that we shall pass here is the axis. I'll give it to one. Then for the dependent variable, I'll use y. Then I'll assign here to cars, and then I'm passing C or to emission. So we also need to import a method from sklearn to create a linear, to create a linear model. So in that case, guys, how to do this? We say what I say from sklearn. From sklearn, import linear underscore model like this, Now we can feed the data to a linear regression to this juncture by first, because we have imported the module. Then here I'll say, for example, I say a regression, say a regre, any variable name. Then I'll assign here to linear underscore model dot linear regression method, linear regression the method, and then let's fit in our independent and dependent variable. I'll say regre dot fit, then I'll pass here the independent variable x, then a dependent variable y, and then what next? Finally, we can predict the carbon dioxide emission based on the gas weight, volume, and also the perhaps even manufacturer. Now what I'll do here, guys, let me first of all create the variable. Let me say, for example, predict CO2. You can use another variable name, predict carbon dioxide. I'll assign here to regre.predict, and then I'll pass here basically inside the tuple I'll pass here what, and these are two-dimensional array. I'll pass here 2300, and also weight can be 1300, right? Basically the volume, right? That's volume, and then perhaps I'll do it. Let me just import some zeros values there, and that we can use the concatenated values. So I'll say, for example, 0 0 sorry 0 0 0 0 0 0 0 0 0 0 0 0 0 0, perhaps 1 0, and then a 0, right? Yeah, they are good. I think these values are good for us to use it. Now so basically with these are values. So basically with these line of code, guys, I can predict the emission of basically a Volvo car. And the way to use 2300, and then the volume is 1300 cubic meters, cubic meters. Now here the print function, we can pass here this variable here, and then let's try to predict and see how it will be. And then guys, you can see the results here. So now guys, we can have a coefficient for volume and the weight. We can have the coefficient for volume and the weight, and each car brand in the data sets. So remember, perhaps let me talk about dammifying. It is not necessary to create a column for each group in your category. The information can be retained using one column less than the number of groups you have. Now, for example, if you have a column representing colors, in that column you have two colors, perhaps red and blue. You'll do it. Let me just show you how I can do that. First of all, I'll say import pandas. Import pandas is what is a PD alias PD, and then I here say, for example, colors. I'll assign here to the PD dot data frame, and then I'll pass here a dictionary. A dictionary is defined using the braces. Then the first parameter key will be color, and then the value is gonna be a list here of colors, perhaps blue, and then the other one is gonna be, perhaps, let me just for the sake of example, let me use also red, and then let me say print colors like this. and then let me try to run first of all and see how it looks like. So guys, you can see how it looks like. Now you can also create now one column called red, where 1 represents red and 0 represents not red, which means it's blue. So to do this, guys, we can use the same function that we used for one hot encoding, get the miss, and also the drop one of the columns. So guys, basically at this junction you can create a column called red, where 1 represents red and 0 represents not red, which means it's blue. So to do this, we can use the same function that we used for one hot encoding, that is get the means, and also we'll drop the one of the columns, so that they may not be true there. So there's an argument drop first, which allows us to exclude the first column from the resulting table. Perhaps let me just show you that. First of all, let me use that method for dummies. So I'll say, for example, let me just say dummies. Then I'll assign here to pd dot get underscore dummies, get underscore dummies, and then I'll pass here colors, and then always I'll say, for example, drop. I'll say drop underscore first method underscore first, and then I'll assign here to true. Then here the print function, I'll say print dummies, or any other variable that you used there. And then so guys, basically here it should be an underscore, not a hyphen, underscore. And then let me run and see, guys, how it looks like. So guys, you can see how it looks like. So guys, you can see it works. But what if you have more than 2 groups? So how can the multiple groups be represented by one less column? So let's say we have 3 columns, the same, like a red, blue, green. When we get the means while dropping the first column, then I will get the another table, the following table. Let me just show you that. Here in the list of values, I'll add here perhaps even, let me say even green. Let me say green, and then here what is here, guys, I'll do what I'll say drop first, drop underscore first underscore first, and then I'll assign here to a true value. Not really. I'll do this. I'll do this, guys. I'll say, let me use dummies here this time. Let me say dummies because I want to append. Let me say, I'll say dummies. Then here I'll do it. I'll target now colors, targeting that colors. Color. Is it colors? Yeah, it's colors. Colors like this. And not really should be color. Let me just use a color. Is it color? And then let me assign here to that colors. Now let me use a colors. Let me use a colors, and then I'll do it. I'll add what this color. I'll add this color, and then let me try to run and see how it works. So guys, you can see how it looks like. So this is how you can do that. You can work with multiple with more than 1 or 2 groups. So guys, basically in a nutshell, this is all about the categorical data. So guys, the other thing that I want us to talk about is the k-means. And k-means is an unsupervised learning method for clustering data points. So the algorithm iteratively divides data points into k clusters by minimizing the variance in each cluster. So guys, here I'll show you how to estimate the best value for k using the elbow method. Then I use k-means clustering to group the data points into clusters. First, let's begin by first visualizing some data But guys, I think you understand how to visualize. But guys, let me just show you once again. So let me say import matplotlib.pyplot is a plt alias, and then here I'll pass here x, and then I'll assign here to some values. Perhaps let me give it a list of values like 4, 5, 10, 10, 4, 3, 11, 14, 14, and then perhaps 6. I'll give it 10, and finally 12. This is for x, and then for y I'll assign it to perhaps let me say 21, 19, and then 24, 17, and then 16, 25, 24, 22, 21, and then 21. And to visualize, remember we use the scatter. I want to use a scatter here, plt.scatter, and then I'll pass here x and y, and then to visualize we use the function called a plt.show function. Let me try to run and see how it looks like. Guys, I can see we have visualized. Now, having these results, guys, I want to show you now how you can utilize the elbow method to visualize the inertia for different values of k. Guys, I remember I'm going to use a different cells, but I remember it will pull data from above here. So let me just say here from my sklearn, from sklearn.cluster import k-means like this, and then data. I'll create a variable for data, then I'll assign here to list. So that is going to be a list for this zip, and then x and y, and then let's create an empty list for inertias. So I'll say inertias. I'll assign here to an empty list, and then I'll use a for loop here. So I'll say for I can use I because I have used x already. I'll say let me use I in a range of perhaps 1 and 11. And then k-means I'll assign here to k-means, and then I'll pass in n clusters, n clusters, n clusters. So assigning it to I, and then our is let's say k-means. Let's fit in some data. So k-means dot fit, then pass in data, and then our is also we need to pass inertia. So let's say inertias dot append, and then I'll pass in what k-means, and also dot inertia underscore. It ends with an underscore. Now basically to do what? To plot, to plot actually use the plt, and then a dot plot, and then I'll plot that range, a range of what? A range of heroes 1 and 11. And then also we'll pass in what? We'll pass in inertias. Then also it will have the markers. I'll assign here O, because I want to have rounded markers, and then the title plt, dot title I'll assign here to, let me use elbow sometime, perhaps let me say elbow method, the title, and then I can have also the x label, plt dot x label, and then I'll assign here to I'll assign here to what, let me say perhaps number, should be something like a number of clusters, for y label is gonna be plt dot y label, and then I'll pass in what inertia like this. Now to visualize, remember the function to visualize it is a plt dot show function, and then let's try to run and see guys how it looks like. So here I forgot, should be k-means, it is should be k-means, sorry. Let's try to run and see. So guys, you can see how it looks like. So it has the elbow, we have the inertia at this section, and then at the number of clusters here. Let me just use a new cell, I think it would be better. Let me just use here a new cell, and then for example, let me say k-means, I'll assign here to k-means, then n underscore clusters, assigning it to 2, and then nowadays let's say for example k-means dot fit, I'll pass in also data, and then let's try to do this. Let's say I want to retrain it with 2, so I'll say so let's say plt dot scatter, and then I pass in x and y, and then c assigning it to k-means dot label, should be dot labels should be labels, and then should be labels, and then remember guys, this should be here. Let me just and then labels, remember it ends with an underscore like this, and then let's close, and then to visualize we use the plt function, the pyplot function, plt dot show, and then what I do, let me just try to run and see how it looks like. So guys, you can see how our data now looks like. So so guys, basically this is all about the the k-means. So guys, the other thing that I want us to discuss here is the Bootstrap Aggregation, sometimes called a bugging, and methods such as decision trees can be prone to overfitting on the training sets, which can lead to a wrong prediction on basically on new data. Now, Bootstrap Aggregation or a bugging is an ensembling method that attempts to resolve overfitting for classification or regression problems. Bugging aims to improve the accuracy and the performance of machine learning algorithms. So it does this by taking random subset of an original dataset with a replacement. So and basically it fits either a classifier for classification or a regressor for regression to each subset. So the prediction for each subset are aggregated through the majority vote for basically for classification, or are the averaging for regression, increasing prediction accuracy. So basically, to see how bugging can improve model performance, we must start by evaluating how the base classifier performs on the datasets. If you do not know what decision trees are, I think you can rewind the video because I had taught it earlier, and then you can just rewind, and then you're gonna have a clue on that. So guys, basically we will be looking on how to identify different classes of perhaps wines found in the sklearn wine datasets. So we start by importing the necessary modules. So let me zoom in a bit for you to see what I'm doing here. So I'll say from sklearn. I think you can see from sklearn. From sklearn, import datasets and then also from sklearn dot model underscore selection model underscore selection import train underscore tests underscore split and then also let's say from sklearn dot metric matrix import accuracy underscore score. Then also I'll say from sklearn. Also I'll also import what from sklearn.tree. I'll import the decision tree classifier decision. What's the spelling for decision here? Decision tree classifier like this. Now guys, next we need to load in the data and store it into the input features in the y that is target. The parameter is frame s underscore frame is set to equal to true, so we do not lose the feature names and basically when loading the data. So guys, basically in this case I'll say I'll create a variable upstream, say data, then I'll assign here to datasets and datasets dot load underscore wine is underscore frame. I'll assign here to true. And then for our dependent variable, independent variable, I'll use x, capital X, remember. Then I'll assign here to data. I remember that is this actually variable that carries this object here. So and then also data. And then the dependent is gonna be data, that object, and then now target. So guys, basically in order to properly evaluate our model on unseen data, we need to split x and y into the train and test. That is x, that is independent variable, and the y, that is the dependent variable. So we need to split them into the train and test set. So for information on splitting data, so you can check. You can just rewind the video and watch that part for train test. I think you have the chapters here at the bottom of the description. At the description section, you can just navigate to the, you can just navigate to the train test section. So basically now that is a decision tree. So guys, basically now I'll do this. Let me just say x, our dependent variable for train, and then also for x for test, and then y for underscore train, and then y underscore test. I'll assign here to train underscore test underscore split. I'll give it what? I'll give it these are values x, and then y, and then test size. Test underscore size. I'll assign here to perhaps some values like even 0.25. Let me give it 0.25. Then also get random underscore state. I'll assign here to 22 perhaps, and then what else? So guys, basically with our data prepared, we can now instantiate the base classifier and fit it to the training data. How do you go about that? So it is d3. Let me create a variable d3. Then I'll assign it to decision tree classifier. Let me copy the method, and then do it. Let me just pass in random underscore state, assigning it to 22 once again, and then d3 now we need to fit it. So it is d3 dot fit, and then I'll pass in what x underscore train, and also y underscore train, y underscore train. So guys, now we can predict the class of when the unseen test set and evaluate the model performance. How do you do that? So it is what I do here. I'll say, for example, y underscore maybe prediction. I'll say prediction, that is for y, the dependent. Then I'll assign here to d3 dot predict. Then I'll pass in the independent variable underscore test for test, and then also now what I do, let me try to execute some things here. Let me say print. So the first one I can say, for example, let me say use a string here, perhaps guys. Let me say train data accuracy, and then here I'll pass in what this argument, perhaps accuracy underscore score, and then I'll pass in y underscore true. I'll assign it to y train and y train, and then y pred for prediction of the y pred. I'll assign it to what? I'll assign it to d3 and then dot predict, and then I'll pass in what? The x underscore train. Now then the other one, perhaps let me just say print. This one is gonna be the test data accuracy, and then here I'll pass in what? Which arguments? I'll pass in accuracy underscore score, then I'll pass in what? Y underscore true to true, y underscore true. I'll assign here to y underscore test, then y underscore pred. I'll assign it to y underscore pred, like this. So perhaps let me just try to run and see how it does. Of course, there's an error, right? At which line here? I forgot something. It should be y underscore train, like this. I think it will work now. Let me just try to run, and then as you can see now, the train data accuracy is 1. You can see accuracy is very, very perfect, but for testing it is 0.8. It is still good, And so basically the base classifier performs reasonably well on the data, achieving 82 accuracy on the test datasets with the current parameters. Remember, different results may occur if you do not have the random set parameter, which we used here. So now that we have a baseline accuracy for the test dataset, we can see how the bargain classifier basically outperforms a single decision classifier. Perhaps, guys, let me talk about creating a bargain classifier. Now, for bargain, we need to say the parameter n estimator. This is the number of base classifier that our model is going to aggregate together. So for this sample, guys, for this sample data set of estimators is relatively low. So it is often the case that much larger ranges are explored. Remember, hyperparameter, guys, tuning is usually done with a grid search. Of course, we talked about the grid search, but for now, guys, I will use a select set of values for the number of estimators. So we begin by first importing the modules, basically the model. I'll say what, so from sklearn dot ensemble import bargain classifier, a bargain classifier like this. And then now guys, let's create a range of values that represents the number of estimators we want to use in each ensemble. For that case, guys, I will do what we say estimators, estimator. Let me just use estimator underscore range, a variable. You remember a variable you can use any name. And then here I'll assign here to some values here, perhaps a list of values, 2, 4, 6, 8, 10, 12, 14, and then 16. And so guys, basically to see how the bargain classifier performs with different basically differing values of n estimator. So we need a way to iterate over the range of values and store the results from each ensemble. So to do this guys, I will create a for loop storing the models and the scores in separate list for visualizations. But you need to note that the default parameters for the base classifier in the bargain classifier is the decision tree classifier. Therefore, guys, we do not need to set it when instantiating the bargain model. Now, guys, here I'll do what I'll create two variables with empty lists for models. I'll assign here to the empty list, and then so let me just say models. I'll assign here to the empty list, and then should be models, and then whereas here says scores, I'll assign here to empty list again, and then I say that I'll use a for loop here. So I'll say for perhaps n underscore estimators, number of estimators, you can use another variable, estimators in estimator underscore range, estimator underscore range, and then what I do, I'll say CLs to create a classifier. I'll say CLF, the classifier dot fit, basically dot fit first of all. Not really fitting, but I'll assign here to, first of all, we must assign to a method here, bargain classifier, and then I'll pass in what n underscore estimators, and underscore estimators, assigning it to the n underscore estimators, then a random underscore state, assigning it to perhaps 22. And then what I do here, guys, let me just say let me say, for example, let me just say clf dot fit then I'll do it. I'll say, for example, x train x underscore train, passing x underscore train, fitting x underscore train, and also the dependent y underscore train, and then I guess we need also to so we have fit the model here with this line of code, and then this other line of code, guys, we created the bargain classifier. Now, guys, here I want us to append the model and the score to their respective list. So I'll say, for example, models dot append, and then here I'll pass in clf, guys, and then the scores I'll append here to accuracy underscore score, and then accuracy underscore score. Then again, let me pass in what? Let me pass in y to true, creating another variable here, y true, and then let me assign here to the y test, and then y underscore pred for prediction. I'll assign here to CLF, basically CLF, and then I dot predict, basically predict, then for x test, x underscore test, underscore test. Now, guys, basically with the models and the scores stored, we can now visualize the improvement of the model performance. How do you go about that? To check it out, we have to import the model here for visualization, of which is Matplotlib. So it is so I'll say import matplotlib dot pyplot is a plt alias plt, and then guys, we need also to generate the plot of the scores against the number of estimators. So in that case, guys, here at the bottom, I'll do it. I'll say, for example, let's say plt dot figure, the fig says I can give it let me assign here to perhaps 9 and 6 the measurements, and then also we need also basically again let me plot now. So plt dot plot, and then it's gonna be estimator, I'm gonna pass in here estimator underscore range, and underscore range, then scores. And then guys, also we need to adjust the labels in the font to make it visible perhaps. So in that case, guys, what I do here, guys, I need to let me say, for example, for x label plt dot x label. For x label, I can say, for example, let me pass in a string. Perhaps let me add in some something here. Perhaps let me say n. It will be n estimator, x label n estimators, And let me perhaps increase some font size again. I say font size, font size. I'll assign here to something like let's say 18. And then for y label, guys, I can say for y label. Let me just do this. Let me just copy. Let me just paste it there, and then what I do, guys, here is gonna be score. I'll use a score, and then I'll change it to y label, and then what is I'll say also I'll add here another function plt dot I'll use a tick here, tick underscore params, the label size, again. Let me give it 16 even. Then to visualize the plot, say plt dot show. Let's be optimistic. It works. So guys, I can see there's a syntax error. Estimate underscore range. Oh guys, basically here I forgot I should have used here two things which don't work. Guys, it's working, right? This one is fine. And so guys, you can see how we've achieved this. So basically this is how it looks like. Perhaps let me try to explain. By iterating through the different values for the number of estimators, we can see an increase in the model performance from 82.2%. Now it is around it is around 95 point something, yeah, 95 point perhaps 5. After 14 estimators, the accuracy begins to drop after 14 estimators, and then the accuracy begins to drop again. If you set a different in a random state, the value you see will vary. That's why the best practice to use the cross validation to ensure stable results. So if this basically in this case we see 13% increase in accuracy score when it comes to identifying the type of the wine. So guys, basically perhaps let me talk about another form of evaluation. Is bootstrapping chooses random subset of observation to create a classifier. There are observations that are left out in the selection process. These out-of-bag observation can be used to evaluate the model, similarly to that of the test set. So guys, keep in mind that out-of-bag estimation can overestimate error in binary classification problems, and should only be used to basically as a complement to other metrics. Now we saw that guys, in the last 12 estimators, in the last 12 estimators here, it yielded the highest score. So we'll use that to create our model. So this time setting the the parameter that is OB underscore to true to evaluate the model with out of bag score. Let me just use a different set here, and then guys, perhaps let me just try to perhaps let me just first of all check load wine. So guys, basically what I'll do here, let me just copy this code here. Let me just copy these codes, and then let me just do it. Let me paste it there at the bottom, and then guys, let me just check where I need to remove here. True, and then train 0.2522, then random state, and then what else should I modify here, guys, for me to use it? Now perhaps let me just try to do this. Let me just delete this code and instead use something else. Alright guys, basically what I do, let me just change the variable here. and then I'll use what? I'll use OOB underscore model underscore model, and then here I'll pass here model, then here I'll pass here what? I'll pass here n estimators. I'll pass here what? N underscore st should be st estimator estimators. Let me assign here to I can give it even 12. N estimators I can give it even 12, and then the OOB score OOB B underscore score I can assign here to a true value, true, and then random state, let it remain 22, and then what else? We need to call it, right? So here should be O underscore B O B underscore score. So, and then here we are passing the X train, the independent variable, and then the Y train. Then here the print function, guys. Let me just delete this many stuff. And then here I'll pass in what? I'll pass in the O underscore model, OB underscore model dot OOB underscore score. It ends with a hyphen. Then let's try to run, guys. Let's just try to run and see how it looks like, guys. And there's an error, right? So guys, I forgot I should have used here B. I forgot that. Let me try to run again and see. And then you obtain what? You obtain these results. You'll obtain these results here 0.9398 and whatever. So basically, this is how you can go about that. And in a nutshell, this is all about the it's called what? The Bootstrap Aggregation. So guys, basically you can find the reference on the website and learn more about these stuff. So I think I have additional stuff on the same. But let me talk about something else. So guys, the other thing, let me talk about the cross-validation in machine learning. Now, when adjusting models, we are aiming to increase the overall model performance on the unseen data. So hyperparameter tuning can lead to much better performance on test sets. So however, guys, optimizing parameters to the test set can lead information leakage, causing the model to perform worse on the unseen data. Now to correct, basically to correct for this, you can perform the cross validation, and to better understand the saving, we will perform different methods on the iris datasets, but let us first load it into the separate data. So first of all, guys, basically what I do here in this cell, I'll say first of all, we import the module. So let's say from sklearn, let's say from sklearn, sklearn import datasets, and then here let me create the X and Y, then assign here to datasets dot load underscore iris, and then I return underscore X underscore Y. I'll give it true value. Now guys, basically there are many methods to cross validation. We will start by looking at the k-fold cross validation. First of all, let's understand what is k-fold. Now basically the training data used in the model is split, into k a number of smaller sets to be used to validate the model. Now the model is then trained on the k1 faults of the training sets. The remaining fault is then used as a validation set to evaluate the model. Now, as we will be trying to classify different species of iris flowers, we'll need to import a classifier model for this exercise. And for example, guys, I will be using the decision tree classifier. We will also need to import the CV modules from the sklearn. So guys, basically let's do this. Let me let me just say from sklearn dot tree import decision tree classifier. What is the spelling for classifier? It should be classifier like this, I think. Classifier, and then also we'll need to import the k fold and also cross val. So I'll say from sklearn dot model underscore selection would import the k fold. We import k fold, and then also we'll import the cross underscore val underscore score. Now guys, basically with the data loaded, we can now create and fit a model for evaluation. How do we do that? So I'll say, for example, let's say CLF, then I'll assign here to what? Decision tree classifier. I think this is spelling classifier like this. Then I'll assign here to random underscore states. I'll assign here to, I'll give it 42 here. So now guys, let's now evaluate our model and see how it performs on each k fold. So in that case, guys, I'll have to do this. I'll have to say, for example, let me use a variable k underscore fold, k underscore folds perhaps. Let me assign here to k fold, and then I'll pass in n underscore splits, give it 5, and then for the k score, I say, for example, scores, I'll assign here to cross this method. Let me just copy, and then here I'll pass here CLF a classifier, and then the independent variable x and a dependent variable y, and what else? As pass here CV, I'll give it k underscore fold, that variable folds like this. So guys, it's also good practice to see how the CV performed overall by averaging the score for all the folds. Now guys, basically what I do, let me just try to execute something here, the print function. I'll say, for example, print, and then above, let me say cross validation scores. I'll pass in what score variable score. I'll pass here score. Basically scores dot mean. I'll use mean as a function. It's a method, and then here let's also do at least not really. Let me just first of all pass here what I do. Let me just copy everything, and then So guys, basically here I'll begin with the scores only, and then the second one is gonna be mean average CV score. I say average CV score, CV score, CV score, scores. I'll pass in what I'll pass in scores, and then I dot mean, and then lastly we need also to pass in what I'll need to pass here. Let's say print. Then I'll have to pass in what I'll pass in the number of CV scores used. Perhaps let me say number of CV scores, scores used in average. Then here I'll pass in this method here to obtain the number. I pass here len and then scores. Remember, the len function will help us to identify the number of scores that were used in the average scores. So guys, I hope it. Let me just try to run and see how it looks like. So guys, you can see now the results how it looks like. So this is how you can obtain with the k with the what with the with the k fold here. So guys, let me talk about the stratified k fold, and in cases where classes are imbalanced, we need a way to account for imbalance in both the train and the validation sets. So to do so, we can stratify the target classes, meaning that both sets will have an equal opportunity of all the classes. So guys, basically how do we go about that? So guys, basically in that case, I'll have just to change here from k fold. I'll use a stratified, k fold. I'll use a stratified. I'll use a what? I'll use a stratified. I'll use stratified k fold. K fold like this, k fold, and then I'll need to change somewhere, right? I'll need to change where else should I pass this method? Stratified the k folds. Perhaps here I'll use for example, let me just say, for example, let me give it a variable. Perhaps let me just say stratified. I'll say, for example, sk underscore fold underscore folds underscore fold. Then here I'll pass in this method stratified k fold. I'll pass this method here. I'll pass this method here, and then guys, basically here CV CV I'll change here to CV here I'll change here to what? I'll change here to sk fold. Now here I should have changed it to sk fold, and then here remain the way it was. So here I'll change here to let me just give it sk fold, and then here should be what? Should be scores. Should be score. Should be score, and then guys, what I do here, of course, here I should have passed here. I should have passed here this one scores. I should have used the scores, and then I think everything is okay here. So what I do, let me just try to run again and see how it will look like. And then guys, basically this is how you can guys, basically you can see it's working very fine. So basically this is how you can obtain the stratified k fold. So guys, let me talk about the leave one out, or sometimes LOO. Instead of selecting the number of splits in the training data set like a k folds, leave one out utilizes one observation to validate, and n number of observation, n -1 number of observation to train. So this method is sometimes quite exhaustive technique. Let me just show you that guys, basically. So in that case, I'll just use should be leave one out. Leave one out like this, and then where else should I change? Let me just copy, and then where else should I change here? So I should change here to leave one out, and then of course here I should have used here I should have used what I should have used here. Let me just pass here an empty what. Let me just pass here an empty method. Let me pass here an empty method, and then here I'll use what I'll use leave one out, LOO, and then what is here I'll pass here in the CV I'll pass here LOO like that. Then guys, let me try to run and see the results, and then guys, you can see how it is the cross validation scores. So basically this is how you can do it. This is how you can obtain that. Now we can observe that the number of scores validation score performed is equal to the number of the observation in the dataset. So in this case there are about 150 observation in the iris datasets. The average CV scores is 94. It is 94%. So guys, basically there's another one called a shuffle split. Unlike a k-fold, a shuffle split leaves out a percentage of data not to be used in the train or a validation set. So basically to do so, we must decide what the train and the test sizes are, as well as the number of split. So perhaps let me just show you another example for the same. So in that case, guys, we use there's a model called a shuffle split. We use this method called shuffle. Shuffle, the spelling for shuffle should be U. Shuffle split. Shuffle split like this, and then split, and then let me copy the method, and then here let me paste it there. So guys, basically here I'll just say, for example, let me just call it SS for shuffle split SS, and then here I'll pass here the basically shuffle split like this, and then train size. I say that you have to pass in the train size and also the split size, number of splits. So I'll say, for example, train. I'll give it train size. Train size I'll give it 0, 0.6, then a test size. I'll give it. Remember, you separate parameters with the comma. Test size I'll give it what? I'll give it perhaps 0.3, and then a number of split n underscore splits. Number of splits I'll give it even 5 like this, and then let's pass here what? SSS. So in this way, guys, you'll obtain what? You'll obtain the. I don't know why it's not working. Let me just try to copy, and then let me just use a different. Let me just close, and then let me just relaunch the notebook. I don't know why it's not working, or my server is not running, but let me just try to again to check it out and see how it works. So here at the end, guys, let me just try to run again and see how it looks like. So this one also LPO. LPO, then guys, basically here should be SS, for shuffle split, and then when you run, you'll obtain so basically the number of splits I should have assigned here to. Let me give it 5. Let me give it again 5, and then shuffle splits syntax. So guys, basically there's an error somewhere, right? I should have separated you separate parameters. I said you separate parameters with a comma like this, and then you'll obtain what? You'll obtain the results here. But guys, remember the LPO, you didn't see that. Perhaps let me try to repeat. My server had was misbehaving. Let me just try to repeat for LPO. So for leave P out, I'll use here LP out. Should be L. Should be leave P out like this. Then you pass the same method, and then here you pass here also LPO. Then here you do what, you just pass here the number of P you can assign here to even perhaps let's say 2. And then here let me use a LPO. Also here LPO. And then when you run, you'll obtain what, I don't know why it's not working when I try to run LPO. It's quite hectic, but guys, you can try it with the others. But guys, these are just a few of the CV methods that can be applied to models. There are many more validation classes, with most models having their own classes. So guys, the other thing that I want us to talk about here is the AUC-ROC curve. And in classification, there are many different evaluation metrics. The most popular is accuracy, which measures how often the model is correct. And guys, basically this one is a great metric because it is easy to understand, and getting the correct guesses is often desired. There are some cases when you might consider using another metric. So basically, another common metric is AUC, area under receiver, operating characteristics, curve, that is ROC, and then basically the receiver operating characteristics, that is ROC curve, plots the true positive TP rate versus the positive, false positive, that is FP rate, at a different classification threshold. Now the threshold are different probability cutoffs, and basically that separates the two classes in binary classification. It uses probability to tell us how well a model separates in the class. Perhaps let me begin with the imbalanced data. So guys, basically suppose we have an imbalanced data where the majority of our data is of one value. We can obtain higher accuracy for the model by predicting the majority class. Guys, let me just show you an example in action here for you to understand. Now we begin by first importing the modules, and the modules that we are going to use here, it is a Numpy. So let's say import Numpy, because I'll use a Numpy array. Numpy is a np alias np, and then also we shall import from isklearn dot metrics. We shall import the several modules here, modules here. The first one is accuracy underscore score. Now the second one can be confusion matrix, because we'll use it, confusion underscore matrix, matrix like this. And then the other one can be ROC AUC curve, and then lastly we need to have ROC curve also. Curve, and then now let's create some variables here that we are going to use here in a few. So first of all, perhaps let me create for n, then assign here to some values, like even let me give it a 10,000. Ratio I'll give it 0.95. Then n underscore 0, let me assign here to let me cast this integer, let me cast this value. So I'll say int, not really, should be, first of all, int should be in int like that. And then here I'll say what, I'll say 1 minus ratio, then I'll multiply by what, I'll multiply by n. And then I always now let's say n minus n over 1, n underscore 1. Then let me assign here to, let me also cast into No, it should be integer to cast. And then here let me pass in what? Let me pass here a ratio. It will pick the values of ratio. A ratio multiply by n. Multiply by n. So now let me use now the numpy array here. I'll say what? I'll say let me just call it y. Then let me assign here to np.array. Then in this array list, guys, let me pass here some logic. So let me pass here, for example, let me say 0, the first index. Then I'll multiply by what? I'll multiply by n underscore 0, and then a plus, and then the second index, which is 1, and then I'll also multiply by what? I'll multiply by n underscore 1, like this. So now I have these values here, these variables, these objects. Now I want us to have probabilities obtained from the hypothetical model that always predict the majority class. And basically the probability of the predicting class is going to be of 1 is going to be 100%, and the other one is going to be for 0 is going to be 0%. It's going to be very, very accurate, though this is not a good practice to use it because it doesn't give you the exact stuff. So what I do, let me just show you with it, then I'll show you how to do it in a proper way. So let me just say y underscore, then let me create my probability here. Let me just say y underscore proba, then I assign here to the numpy np dot array, and then here in this list, in this array list, guys, I'll pass here some values. So let's say index 1 here, multiply by n times n times n. Then now also let's create now the values for the prediction. So I'll say y underscore pred. This one is gonna take y proba, and then the values of proba which are greater than 0.5. So guys, let's now execute some things at the terminal. So I'll say, for example, print. Then here I'm gonna use the f string. Let me use an f string here. And then in this f string, guys, I'll pass here, let's say something like accuracy score. And then what else? Here, let me just pass here some set of values should be inside this. So here, guys, I'll say, for example, accuracy underscore score, accuracy underscore score, accuracy underscore score. And then I guess I'll create also here a tuple where I'll pass y, and then also y underscore pred, and then what else, guys? Also I need to create the variable for confusion matrix. So let me just say, for example, cf underscore mat for confusion matrix. Let me assign here to confusion underscore matrix, and then I'll pass here what? I'll pass in what? Y, and also the values. I'll pass here also y underscore pred. And then now, guys, perhaps let's try to print out, let's say print confusion matrix, And then in this confusion matrix, perhaps let me pass that variable so that it can return the values of the confusion matrix. So it is CF underscore mats confusion matrix. And then always let's also execute some accuracy score for the 0. So I'll say, for example, print, and again I'm gonna use what I'm gonna use the f string. Let me use the f string here. Then in this f string, let me say give it a class. Let me say class. Actually, I want to execute some things at the terminal. So class of 0 accuracy, so that we may understand, we may relate. 0 accuracy. I'll assign this value so that it may return the accuracy score for the 0. And so I'll pass here a set. Then I'll say cf underscore mat. Then I'll pass in what? I'll pass here 0. And then also 0 over what? Over n underscore 0 underscore 0. And then of course this string should be closed here, should be here. This string should be where? Should be here. And then what I do, guys, let me just duplicate, and then I make one for 1 accuracy score. Let me just copy, and then I do it. Let me just paste it there, and then here I'll give it 1. Also here I'll give it 1, and then here I'll give it 1. Let me just try to run, and I believe everything will work out. Let me just test and see how it will look like. So invalid, perhaps you forgot a comma. Let me just, or what I do, let me just separate this as CF from another. Let me just say print. Print dot. Let me just print separately. These are CF. Confusion matrix. This one is a string. I don't know why it's bringing some error. I cannot import ROC from sklearn. Oh, guys, let's try to check it out and find where the problem is. And so should be confusion matrix, right? So it is ROC underscore AUC underscore curve. What's the problem here, guys? Oh, it should be first of all ROC score, not curve. Sorry, should be score. I think I imported the wrong module. Score like this. Then let's try to run and find another. Yeah, guys, it's working very fine. Well, you can see, guys, it has outputted what this accuracy score, and although we obtain a very high accuracy, as you can see, like for 1 here, I should have changed here to 1 because I'm using 1. So you can see for 1 we got an accuracy of 1, that is 100%. That is very high accuracy. And then for 0 we got a 0.00 accuracy. You can see that is very high accuracy. Guys, basically at the expense of accuracy, it might be better if we have a model that can somewhat separate the two classes. So guys, basically in that case, let me just try to modify a bit my values here. And let me use a different cell. Remember, it will pull data from the above cells. So let me say, for example, y prober underscore 2 underscore 2, and then here I'll do it. Let me assign here to the numpy np underscore array. Then in this array list, guys, I'll pass here what? I'll pass here np dot random dot uniform, should be uniform. Then here I'll pass here some values, 0, perhaps 0.7, then also n underscore 0, then to list. I'll use here this method called to list. And then I'll add it to. I'll also add allows add np dot random dot uniform distribution uniform. Then I here I'll pass here 0.3 1, and then also n underscore 1 this time, also to list. It should be to list also, to list method, and then guys are basically the other thing. And the other thing guys are here we should also have y underscore prediction to pred, and we'll compare the values predict to. This accuracy score is gonna be low a bit, but it's gonna be kind of realistic. So let me say y underscore prober, and then I'll assign here to something like let me give it even y prober underscore 2. Remember I'm pulling this the value here. Then this one again is gonna be above above 0.5, and then what I do guys, let me just pull these strings here. I don't want to repeat these stuffs again. Let me just do this. Let me just copy, and then let me paste it down here. But here I'll change here to pred underscore 2. Also here I'll change here to pred underscore 2. Where should I change? I think everything is okay. Let me just try to run and see how it looks like. So NP array is not defined. Is not defined, guys. NP array, Numpy array. Oh, I should have used. Did I use? Yeah, it is Numpy as I don't know why it's not np. Oh, should be np dot array. Sorry, should be np dot array. Sorry, I forgot that. And then let me try to run again and see. Here, guys, you can see now the accuracy score is a bit low. You can see 0.714 for 0, and then for 1 it is 0.71 0.7173, and so forth. So guys, as you can see, for this second set of prediction, we do not have as high accuracy score as the first one, but for each class it's more balanced. You can see the first one was 100% for 1, then if it is 0 it is 0.0. But using accuracy as an evaluation, we rate the above this one, the first one, to be higher than the second, even though then it doesn't tell us anything about the data. Now in cases like this, using another evaluation metric like AUC would also be preferred. So like let me show you that guys also how we can use AUC. So we import first of all Matplotlib. Let's begin by first importing Matplotlib, because I've learned us to visualize something there. Also import matplotlib .pyplot is a plt alias plt. Let's now define our function here. Let me say df. Then let me say plot underscore ROC underscore curve. Then here I'll pass here true. True underscore y, and then also y underscore probe should be probe, and then let's close here with a colon, and then now here let me just say so guys, I basically want to have a plot for the ROC curve based on the probabilities. So what should I say? So let me just say f PR, the first variable here, TPR, the second one, then also the threshold. Threshold, should be thresholds. Let me assign here to what? Let me assign here to ROC curve, ROC underscore curve. And then here I'll pass in what I'll call that these stuffs that we defined here. Let me just copy. And then let me just pass there. And then what I do, guys, next, let me just also say plt. Let me say plt dot plot, and then we are plotting what? We are plotting fpr tpr like this. And then for x label, let's say something like let's say plt dot x label what is the spelling for label? Should be label, right? Like this. And then here I'll say what? For example, let me just say false positive rate, and then let me copy, and then to this new line, let's say y. Let's say y, and then let me say here true. Let me say true. Let me say true. Positive what? True positive rate. And then now, guys, basically now let's call this function now. How do you call it? Let's say plot. Remember how to close a function, how to call a function, sorry, to plot arrow. So what I do, let me just copy this name. You must use the exact function name that you use to define your function. And then here I'll pass in what? I'll pass here y, and then proba. These are arguments. Proba y underscore proba, y underscore proba, and then now, so after that, guys, also let's print something here, and then I'll use the f string. I'll use the f string here, and then inside this f string, let me pass here what? Let me pass here model 1 AUC score. AUC score, and then I'll pass here this set and say ROC underscore AUC score, and then here I'll pass in what? I'll pass here y, and also y underscore proba. So guys, I want us to check how it looks like. First of all, these quotes should be here, closing quote, closing quote. Let me first of all delete this one, closing quote here. So let me just try to run and see how it will look like. So guys, you can see how it looks like. It is a straight line, and let me just, yeah guys, as you can see, it is a kind of a straight line. And let me perhaps show you another example with y proba 2. Remember, this is the first one. We had two values here. We have for y proba and then we also have for y proba 2 here. Let's test with the second one and see how it looks like. Remember, this one accuracy score is very high. Very high. So guys, basically now I want to modify a bit, and I use the second values. So it was the second one was a proba underscore 2. Also here I'll use a proba underscore 2, and then also here at the bottom it should be proba underscore 2. Which values am I using, guys? Probe underscore 2, right? And then our arrays here also should be probe underscore 2. Not really here. Let me just close here, prober there, and then here, guys, basically what I'll do here, let me just even here should be probe. Let me just say probe like this. Probe, it was probe. Remember we defined it somewhere, and then here, guys, it should be now probe underscore 2 underscore 2, and then our arrays it should be something like probe underscore 2 also here. So what I do, guys, let me just try to run and see how it will look like. So here I'll change perhaps, let me just say 2. Where is it? Yeah, let me just say change here to 2, and then let's compare. So guys, you can see now the second one how it looks like. So remember, the accuracy is not as high as the first one, but it's kind of realistic. Now you can see an AUC score of around 0.5 would mean that the model is unable to make a distinction between the two classes, and the curve would look like a line with a slope of a 1. An AUC score closer to 1 means that the model has the ability to separate the two classes, and the curve will come closer to the top left corner, as you can see on this other case. You can see initially it was just a straight line, then as now I think it's kind of good to separate your values like the way you can see. So now, guys, basically perhaps let me talk about the probabilities. Because AUC is a metric that utilizes probabilities of the class prediction, we can be more confident in a model that has higher AUC score than one with a lower score, even if they have similar accuracies. So guys, I want to give you some data below here, whereby, guys, we'll have two set of probabilities from a hypothetical model. The first will have a probability that that are not as confident when predicting the two classes. That's the probabilities which are close to perhaps 0.5. Then at the second one we'll have the probability that are more confident when predicting the two classes where the probabilities are close to extremes of 0 or 1. So guys, without much ado, let me just show you for you to relate well. And so first of all, because I'm using here the Numpy array, I'll first of all import Numpy. Numpy is what? Is the NP alias. Then here let me create the values for n to something, actually a variable to something like even 10,000. 10,000, and then also y. Let me assign here to the Numpy np.array. Then in this array list, guys, I'll do it. I'll pass in here 0, and then multiply. I'll multiply by n, and then a plus 1, and then also I'll multiply by n, multiply by n, and then now, guys, now let's create for, and then guys, here say, let's say y underscore probe underscore 1, sorry, underscore 1. Let me assign again to the Numpy array np.array, and then here I'll pass in np.random np.random np.random.uniform, and the uniform. Then here I'll pass in 0.25, then 0.5, 0.5, then n, and then over 2, then to list, let me say to list method here. I'll add np dot random.inform and then in this one I'll give it what I'll give it let me say how should I give it? Let me just pass in what? Let me pass here these values. Let me say, for example, 3.0, basically 0.3. Let me use a 0.3, and then also 0.7, 0.7. Then also 0.7. Then 0.7, and then here I'll pass here what? I'll pass here. First of all, should be a comma. Then I should be n here. I'll use n. I'll use n like this, and then and then also I'll pass here the method. Let me call it to list a method like this, and then lastly let's also concatenate to it. Let's say plus. Let's say plus what? Let's say plus let's say plus let's say plus again a plus. These are np dot random, np dot random dot uniform, np dot random dot uniform, and then I'll pass in what? I'll pass in 0.5 again, then 0.75, and then also lastly it is n over 2, and then also I'm gonna pass the method called what? To list is a method, and then what else gives let's now create and the second one with prob 2. So let me do this. Let me just copy, and then I'll paste here, and then here I'll change the values from 1. Let me use 2, and then here let me perhaps change the values here. So here the first one should be like let's say even 0, and then the second one can be even 0.4, and then the third one can be what? Can be n over 2. Let it be the way it is, but here it should be what? Something like let's say 3 and then a 0.7. This one can be the way it is, and then the last one, let me use 6. 6, and then here perhaps 0.7, just 7, then n over 2, and then guys basically let's print out something here at the terminal. I'll say, for example, print let's say print, and then let's say let me use an f string here, and then in this f string guys I'll say, for example, model 1 accuracy score, model 1 accuracy score. Then here I'll pass here this set. So I'll say what? I'll say y, and then also y underscore probe. Basically it should be probe underscore 1, probe 1, probability 1, and then here being greater than perhaps let's say 5, and then of course guys here should be what? Should be this stuff should be what so guys, basically here should be, let me just first of all, accuracy score. I should have passed here guys accuracy score inside this dictionary here, and inside this set. So I'll say accuracy underscore score, accuracy underscore score. Then let me pass in this tuple, and then once you're passed there, also let's remember to close here at the end. So accuracy score, and then you pass that. You pass this set here, and then what I do guys next is to do it. Not here should be 0.5, and then so guys basically the next thing, let's obtain the for the second what, for the second model. So let's say for the second model to be 1, then here I'll change it to 2, and then let's say also here where a probe I should be here, just probe 2 should be probe 2 like this, probe 2, and then the other things the way it remains the way they are, and then here guys perhaps let me say print print what print you know, or guys basically what I'll do, let me just copy these stuff, because I want now to obtain the AUC score, but let me perhaps try to separate a bit, and then this model should be for AUC score, AUC score, and then here it should be AUC score, should be ROC underscore AUC underscore score underscore score, and then so I think let me just do this, let me just cut, then let me copy this one, and then let me paste it there, and then I guess basically I'll change here to 2, let me change here to 2, and then then here should be, let me also change here to 2 then guys let me just try to run and see how it will look like. Alright, before then let me just plot, let me say let me also plot ROC underscore curve like this, underscore curve, then I pass in what this one is for model 1, so let me say y, then comma, and then a y underscore probe. Oh guys, before that let me just run this example, let me just run this one, and then I see how it will look like. Let me so guys basically there's a problem here, where so here should be np, also here should be np. Now let me run again and see how it looks like. So guys basically you can see now guys basically when you try to plot, let's try to plot and see how it will look like. So perhaps let me just use this new cell, and then let me just say plot underscore ROC curve, then I pass in y, and then also y underscore probe underscore perhaps 1, the first one. Let's try to run and see how it will look like, and I guess you can see how it looks like. Perhaps let me also have for the second one, for the second model. So I'll say for example it was FPR, TPR, then a threshold. Or I guess basically what I do, let me just copy, where was it? let me just copy this one. Let me just copy this one, and then let me just paste it there. Let me paste it there, and then threshold and then so basically, oh, here I should have removed this indentation. And threshold, this should be y, then our probe here should be probe 2, probe underscore 2 for the second probability, and then here we are passing a FPR and also TPR. Then let me just try to run and see how it looks like. I'm hoping everything is okay. Let me just run, and then oh guys, basically here I should have removed what? I should have removed this one. Let me remove that one to be y, comma, then the second argument should be y probe underscore 2. Then what I do is let me just try to run and see how it looks like. Yeah, and then I guess you can see now the second how it looks like. So guys, basically, even though the accuracies from the two models are kind of similar, you can see they are quite similar. Basically, the model with the higher AUC score will be more reliable because it takes into account the predicted probability. It is more likely to give you a higher accuracy when predicting the future data. So now, guys, basically this is in a nutshell all about the AUC, and basically this is all about the AUC-ROC curve. So guys, lastly, let's talk about the k nearest neighbor, sometimes called KNN. Now, KNN is a simple supervised machine learning algorithm that can be used for classification or a regression task, and is also frequently used in machine value imputation. So it is based on the idea that the observation closest to a given data points are the most similar observation in a data set, and we can therefore classify unforeseen points based on the values of the closest existing points. Now, by choosing a k, the user can select the number of the nearby observation to use in the algorithm. So here guys, I'll show you how you can do it, how you can implement the KNN algorithm for classification, and I'll show you also how different values of k affect the results. First of all, how does it work? K is the number of the nearest neighbors to use, right? For classification, a majority vote is used to determine which class a new observation should fall into. Now, larger values of K are often more robust to outliers and produce more stable decision boundaries than the very, very small values of the K. That is, for example, if you have, I'm going to show you an example, guys. For example, K being 3 will be better than k being 1, which might produce undesirable results. So perhaps guys, let's begin by first visualizing something here. And so to visualize, guys, we use the Matplotlib. Let me first of all zoom in a bit. So I'll say import Matplotlib matplotlib.pyplot my matplotlib.pyplot as a plt. Let's create the values for x. Then let me assign here to 4, 5, 10, 4, and then 3, and then what is perhaps 11, 14, and then 8, 10, and then perhaps 12, 12, and then for y I'll say I'll say I'll say 21, 19, 21, 19, 24, 24, perhaps 17, 16, 16, then 25, perhaps 25, and then 24, 22, 21, and then lastly 21. So for classes, let me create the one for classes. Classes, I'll assign it to 0, 0, perhaps again 1, 0, 0, 1, 1, 0, 1, 1, perhaps. And then here, guys, perhaps let's try to visualize. So we'll plot the scatter first of all, plt.scatter, and see how it looks like. So I'll pass here x, should be x, y, then for classes I'll use c, then assign here to classes, and then to visualize, guys, you remember the command plt.show function. And then let me try to run and see how it looks like. So guys, basically this is how it looks like, right? This is how your data looks like. And then now, guys, basically now we fit the, let's try to fit the KNN algorithm with the k perhaps 1. I said that I will try with the k1, and also we shall try with another one with k being perhaps of a higher value. So so guys, basically in that case, what we do, let's say let me use we have to import the modules to handle that from sklearn. So first of all, let me zoom in. So I'll say from sklearn dot neighbors neighbors. This is the spelling for neighbors. So let's say import k neighbors module neighbors. You don't know if this is the spelling for neighbors. I guess neighbors classifier like this, and then I'll pass in what n underscore neighbors neighbor and underscore neighbors. Let me assign here to 1. Basically not really assigning. So let me just so here we just import the module, and then above let's create the variable here. Let me say data, then let me assign here to list, and then here I'll pass here zip, then inside this zip I'll pass here also x and y. Remember, it pulls the data from above here. It pulls the data from the above cells, so that's why I don't have to repeat the same thing. Now let me also create for the one for KNN, k nearest neighbor. Then let me assign to KN. What I do, let me just copy this class and I use it as a method here, classifier, and then here I'll pass in what n underscore neighbors. Neighbors, I think should be some h somewhere. Neighbors. Let me assign here to 1. Then also let's now fit the data, the KNN. So KNN dot fit. Then I will pass here what data, and also classes. Should be classes like this. And then guys, what I do, so guys, we can use it now to classify our new data. How do we go about that? So for example, let me just, I'm hoping everything is fine here. So let me just insert a new cell, a new cell here, and then guys, here I'll say what. So for new I'll say new perhaps new x, new underscore x. I'll assign it some values like let's say even 8, and then what else? Let's say new y, new underscore y, and then let me assign here to some values like even 21, and then a new underscore point, let me assign here to there's a list new underscore x, and then the other one is new underscore y, like this. And then let's create now the variable for prediction here. So let me just call it prediction. Then I'll assign here to the KNN. Remember to post the data from this above cell, and then here guys I say dot predict. Predict, and then I'll pass here new point, new underscore point, like this. And then guys basically to visualize or to draw the scatter, we'll use PLT and dot scatter. Then in this scatter guys I'll pass in what? I'll pass here x plus what? Plus new x, new underscore x. Then the second argument here I'll pass here y plus new, should be new underscore y, and then also I'll pass in here the classes variable. Let me pass here C for classes, C classes, Then also I'll pass here I'll concatenate with the prediction. I'll say prediction, and then at the first one I'll use a 0, and then what is so now basically for the text here, let's use a plt.text, then here I'll pass here x, assigning to new underscore x, perhaps minus 1.7, and then also new y, underscore y, let me assign it to new underscore y, this one should be minus what? Minus 0.7, minus 0.7, and then what is what else should I pass here guys? Let me also use the string here. So let me say s, then assign here to the f string, and then here in this f string I'll say, for example, new points, new point, perhaps let me just say new pointer class, then here guys let me just pass here this set. Remember this one is a placeholder for prediction, so it will pass the prediction. We always use this asset to add to be like the placeholder to carry that prediction, a variable prediction. Then here I'll pass here 0. Now to visualize we'll use plt.show. Let me try to run and see how it will look like. So guys basically there's an error, right? It's not defined, KNN is not defined. So guys basically what I'll do guys, let me just try to, because we didn't run this stuff, let me just paste it here, and then what I do, remember we didn't run, so it's so guys basically we get this error, and of course guys here I think it should be basically I think the error should be here, right? So here guys basically here it should be inside the tuple, for to show that it's a two-dimensional array here. So I'll just pass here tuple like this, and I think it might work. Let me just try to run and see how it will look like. Yeah, as you can see, it's working. It's working very awesome, and you can see how it looks like. So now we do the same, but with the higher value with the changes in the prediction. Let's try that, and guys, basically, first of all, let me just copy the from KNN. Let me just copy it to this point, and then guys, I want to try, but with a higher value for n neighbors. Perhaps let me give it even 5. Let me give it even 5, and then guys, what I do, let me just try to run and see the difference there. Let me just try to run, and then guys, you can see you know, the output. You can see the output here. So guys, basically, perhaps let me try also to explain these stuffs for you to get it well. So where do I begin? So guys, basically, let me begin from here. I try to explain these commands because I think I didn't uh, tell you well. So guys, I will begin by first importing the modules. Now in this first case, we imported the Matplotlib, and then we also imported the sklearn here at the bottom. But now here with these three variables here, now we created the arrays that resembles variables in datasets. So we have two input features. We can assume this is our dataset. The first one is x, and then the y, and then we created the target class, which we called it classes. We call it classes. Now the input feature that are preloaded with our data with our target class will be stored to predict the class of new data. Um, but while we only use the two input features here, this method will work with any number of variables in this case. Now guys, basically the next thing now, the next thing now guys, basically is to do it is to we turn the input features into a dataset with what? With this line of code. Where is it here? With this dataset, and then so basically using the input features in the target class, so we fit the KNN model on the model using the one nearest you know, or closest neighbor here. And then guys, then we use the same KNN object to predict the class of new unforeseen data. And by doing that, we first you know, created the new x and y, new x and y. And then I gave it some other values, like in this new x we gave it 8, then a new y we gave it, you know, 21. And then we called that prediction. We call it, and then you can see here. So guys, basically this is all about machine learning, and I really celebrate with you for completing the machine learning course. This is so great, and I appreciate you very much guys for commitment. And I know by now guys, your skills is now at a higher level. And guys, if you find the video has been of help, please now consider subscribing, like and share the video to your friends. And I think guys, up next I shall begin the full stack development with Django, HTML, CSS. So guys, you might also want to subscribe if you are interested to learn those stuff. So be sure to subscribe and also like this video. See you then guys. My name is Nehemiah. Goodbye.